Hi Rocketeers, how's it going? Let's quick audio check. Can I get an AOS? We have everything working. I've got a new streaming setup in a different room, and I think it's going to be much awesomer than streaming setups in the past. But we'll have to make sure there's no technical difficulties. Wow, how about that latency? Okay, I think that's everything working though. So, I think that means it is time to dispense with the procrastination and pleasantries and dig into this. So this is the LEGO Ideas Space Station Construction Kit, and I am just absolutely a huge fan of LEGO doing NASA everything. This is just very exciting. I love the Saturn V. And then they did the lunar lander, and now they're doing this one, and it is just making my life. I am very enthused by all of this. So we'll crack into it. How's everyone else doing tonight? I just got off work for the evening and decided to be completely and utterly unproductive and build more Legos. Okay, wow. Okay, so we got the box here, and I think let's see if this works. Boom. All right, here we go. All right. Oh, I'm so proud of myself. I worked on the live streaming setup real hard yesterday to get it all sorted. So we've got lots of bags of parts, and they are supposed to be assembled in a very specific order, laid out in this book here. This is supposed to tell us how all of these things work. But the problem is, they didn't build the space station like this. They didn't have instructions. There were lots of instructions for how to build the space station. But this were not them. So what we're going to do instead is, thanks to the wonderful people on Twitter, I have a alternate construction order that replicates the order that the real International Space Station was assembled in. And we're going to go ahead and try and do that. All right, let's see how fun this is. I think the first thing I need is bag one. Bag one, right here. Okay, we will sort the rest of the bags over to the side for a moment and crack on with this one. Joey Murphy, hi Joey, how's it going, man? Would like to know how hard it would be to 3D print a Dragon 2 to scale, and the answer to that is hopefully not very hard, especially if you have like a resin printer. I think that would work pretty well. I actually have a super great Dragon 2 capsule model. I saw the game that SpaceX released the other day where you can try and dock the Dragon spacecraft. But the problem with that game is it's not actually all that accurate. It's just like a Cartesian microgravity simulator. It looks really pretty, but it doesn't actually do any of the interesting orbital mechanics that happen when you're trying to do docking and rendezvous. Which, mind you, Kerbal Space Program kind of does, but as was pointed out to me on Twitter, also it fails to capture a lot of the interesting ones. So I dusted off my dynamics textbook, and I've been trying to make a Unity-based game to let you dock the Dragon, but with realistic physics. We'll see how hard it is. Also, it took forever. I started trying to do it in Pygame, and I spent longer in Pygame than I did downloading Unity and just starting there. So I should have started that. Okay, so this is a bag of parts, and I think after throwing away the instructions, the very next thing we have to do is get the instructions back out, because this will tell us how to make bag one get assembled into the Dragon spacecraft, I think, and the space shuttle. I don't know exactly what all we're supposed to put together. Yeah, so this is going to make one Dragon spacecraft, one Cygnus spacecraft, and a space shuttle, I think, is what is going to come out of this bag. So we begin at the beginning with bag 1. And I need this piece, a gray one of those pieces, and a 1x1 black dot. And it looks like the assembly is highly straightforward, where you put the black dot on top, then put the gray piece on top of the black piece, and then put that whole assembly together, and you get this widget right there. I actually don't know what this is. Does anyone know what capsule this is supposed to be? Okay. Thank you, Ian. I'm doing well. I'm having a wonderful afternoon. Oh, Colin, good luck on your AP Chem exam. I didn't do any AP classes. I didn't go in for any of that. So I've just heard that they're really challenging, so good luck to you. Am I a Knoller? Yes, I'm a Knoller. I would, if I were not streaming, spend several hours organizing these parts before I built anything. In fact, even though I am streaming, I might do so anyway. It seems a pro to do. Adam Savage is just like the coolest guy ever. That guy is just awesome. Okay, so this is going to take forever if we spend 2 minutes to a page. The next thing it looks like we get to build is Dragon, which is going to start with this right here. This is going to be our trunk. And I need 2 of these handles. And these go into the side. And then like a white dot for the bottom. And a cone? Is there a cone piece? Yes, there is a cone piece. And a cone piece for the top. And then the panels. Like these. These are just... Holy cow. Get a load of the like solar panel to dragon ratio in this part. It's just like... Woo! It's a lot of solar panel and not a lot of dragon. This is not focusing. Super awesome. I'm not sure if I can make it focus, but yeah, there we go. That's a little better. Okay. Good morning, Dylan. Joe thinks that we can build the ISS with the Pizza Hut rocket, which is sure. Okay, Pizza Hut rocket. We'll call the shuttle that. All right. Oh my gosh. Okay. I'm gonna stop reading Joe's messages in the chat as he continues to abuse pizza rates. Okay. How did I get into MIT without AP tests? I applied to MIT, had good grades, I got in. Probably wrote good essays. That probably helped. Does anyone know if Charlie is human? Guerrero, I can confirm that Charlie is human. Definitely. 100% for sure. Does the trunk have a teeny tiny pair of calipers inside? Joey, Dragon has never, ever, 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 ever orbited a pair of calipers. I can categorically state that. Plot twist, Charlie is alien and trying to teach people how to build rockets to get back to his home planet. No, I think that's Elon. I'm definitely human. If I was alien, I would be smarter. Okay, we're putting together Cygnus next. So Cygnus starts with this dot, and then it needs a white dot, and then a gray bar, like this. There we go. Let's see. And then after the gray bar, it needs this, like, black sphere? Oh, this might be Progress instead of Cygnus. That seems likely. I may have lied to everyone. I think this is a Progress and not a Cygnus. It seems like a safe bet given that it has this, like, round bit at the end. That feels like a very Russian thing. Okay, so put the solar panels on. All right, so here we have our visiting vehicles complete. I think this is the CST-100. I don't actually know what it's supposed to be. And then we've got Progress, and then we've got a Dragon. Excellent. I just set those on the page I need to turn. Folks, I still haven't even opened the bottle of wine yet, and this is already where we're at. This is going to be a really entertaining evening. Okay, Let's see. Joey, no, I'm actually not familiar. Did they launch a Delta 2 with the Pizza Hut logo? That feels like an interesting piece of branding that I'm surprised they got away with. I didn't realize that was a thing that could be allowed to happen. Okay. Oh, Proton. Okay. Proton seems more feasible than a Delta 2. That makes sense. I guess that must have been one of the first launches of maybe Zvezda or Zarya. It's just been too long since I thought about the ISS modules. Okay. All right. Next, Space Shuttle. So we need one of these black pieces. So these black pieces right here represent the silica tiling on the underside of the Space Shuttle. And the silica tiling was actually not the highest temperature material used on the Space Shuttle. There was, on some parts of the Space Shuttle, material called reinforced carbon-carbon, which was gray in appearance. And it's a 3D matrix ceramic composite that is very, very high temperature, and it is wonderful stuff. It's just, you know, a little bit expensive. I think it was like $100,000 a square foot when they built the space shuttles. I think it's gotten a little cheaper since then, but still not the cheapest of things. Okay, so then we've got this little gray piece. I don't know what this little gray piece is for. It's kind of like weirdly like oval shaped. So we've got this, and then we flip it over. Wow, this is already not the most structural thing I've ever put together. So I've got this, and like I can do this, and it like wobbles. The space shuttle wings should not be able to do that motion. I guess maybe it's the flaps. They've designed in the ailerons, elevons from the space shuttle. Yeah, elevons they must be because they do both pitch and roll, and then the tail does yaw, and then it's got the body flap in the back for extra pitch authority. Cool. Okay, so these are just more tiles on the bottom side of the space shuttle to make it nice and shiny, which looks cool. Flip it over. We've got these three pieces. Then we need this three-piece up here. So these white pieces, they represent what were called low temperature flexible surface insulation, something like that, LRSFI or something, low temperature reusable surface insulation. They were essentially stitched Nomex blankets that were on the outside of the top side of the space shuttle. There were some white tiling too, but mostly it was blankets. Okay, so we've got this part of the space shuttle built up. And now they want us to add the last of these like weird ovally bits, and then one of these black pieces in the front, and then a long white piece, which we can do. I lied when I said the last of the gray ovally bits because there is in fact one more, but we need to add one more of these little Scooby-Doos that have the like clicky pieces. Okay, what comes after that? So these two little right angle pieces go up here and off to the sides. Oh, so these are going to be where the ohms pods mount. So the ohms are the orbital maneuvering system, which are represented in LEGO by this weird piece here. I need one more zoomed camera if I've been thinking through this. So they were the orbital maneuvering system, so that was what allowed the space shuttle to adjust its orbit after it's dropped its external fuel tank. And they burn hypergolic propellants, hydrazine and nitrogen tetroxide, and that is relevant to me because the job that I do now is I work for a company that builds hypergolic thrusters for in-space maneuvering, and it is a really cool job. I mean, aside from the odd chance of death by hydrazine, but it's still a really cool job. Okay, so we got the shuttle body kind of mostly put together, so I guess the next thing to do is to add this plug in the front, and then two of these bits that go all the way at the front. There we go. Getting away from me. So the space shuttle was built by Rockwell International, and Rockwell Aviation was eventually bought up by Boeing. So the company that built the space shuttle was actually out of business long, long, long before the space shuttle stopped flying. It was built out in California. They were like about $1.5 billion a piece back in the day. So the real problem with the space shuttle program, I mean, a lot of people say it was dangerous, and the space shuttle was getting a little dangerous to fly, but the real problem was that they were running out of space shuttles. They couldn't keep the program running if space shuttles kept getting lost in missions, because they didn't have the capability to build more space shuttles. Okay, so now we need one of these gray pieces. This gray piece, this is what I was talking about when I said reinforced carbon-carbon. It's this gray stuff. So you can always see where it is on the real space shuttle. You can tell every space shuttle apart by the pattern of the heat insulation. They all have slightly different tile and heat shield patterns. Also, the wings are different, but if you can see the wings, it's cheating because they write the names on the sides of the things. Okay, so we got this. Now we need to do these little white tiles here. They go back here. Where do these go? Oh, weird. Okay, cool. Cool, cool. So one tile there, and then one tile on top of that, and then this black sloped piece. Oh, guys, this is cool. Check this out. Look at the front of that. That just came out so nicely. I love it. And then this piece goes here. This piece goes here. Oh, wow. It's just, I love it. It came out great. I'm still not sure what they're doing here at the back. Those don't look like engines, like, even at all, but we'll give them a pass. Oh, now you know I can make the engines. I spoke too soon. So to make the engines, you take one of these click pieces, and then one of these pieces, and then one of these pieces, and you've got an engine. I'll make three. All right. I kind of want to zoom in. Can I zoom in? Yeah, I can do this. Watch this. Aerojet Rocketdyne. You're charging $148 million for this little bit right here. Why? Why? Every SLS mission is going to have $500 million of rocket engines on it. And they aren't even reusable anymore. They're really nice rocket engines. And Aerojet Rocketdyne does build good engines. Don't tell my boss I said that. We're supposed to be building better rocket engines than Rocketdyne. But they do build good rocket engines. The problem is just they're so expensive. Holy cow. Okay, I built 3 RS-25s in less time than it took them to convince a senator from Alabama to pay for them. And now, oh wow, that just does look awesome. Check it out. Engines. Oh, my workbench. Engines! Okay. Now I'll read the chat, which I should have done a long time ago. Sorry. Okay. Charlie, do we think it's okay that I've been writing in the chat in my online school meetings in Musk we trust? Well, Elon Musk is a polarizing figure. And I would love it if he took the ongoing global health situation slightly more seriously. But we can't have everything. You know the situation, act appropriately. Okay. In the interest of space trivia, does anyone know why the ISS's TLEs are always labeled ISS Zarya? You know, Joey, I would guess probably because Zarya was the first module up, probably so that if like they start taking the thing apart again, it's not ambiguous what is the ISS and what is not the ISS, but I don't know for sure. Okay. Joe indirectly reminds me to open the wine. Yes. So Joe is being productive, and I should be being productive, but I'm not being productive. I'm building Legos, which is a lot more fun. Okay. Am I a NASA or a space guy? I hate that question. It's just so inane. I'm a space guy, and NASA and SpaceX both do space. So this is a Dulce Rosetta, which is supposed to be like a little sweeter. So we'll see. Smells pretty good. Yeah, that's a little sweeter. And it's kind of sparkly, too. That's an interesting, I like it. Very tasty. Okay. Death by Hydrazine would be a good band name. Yes. And it would be a really short-lived band, I'd have to guess. Let's see. Are there any mods here? I'm a mod here. I'm the only mod here. Matthew Pryor wants to know. Oh, your grandfather worked on the ISS. Yes, that Zariah was the first module. That's really cool that your grandfather got to work on it. Joey Murphy suggests we test to see if the space shuttle has the same glide slope as the real space shuttle. For those of you who don't know, the space shuttle has a glide ratio of about 3 to 1, which means that for every 1 feet it falls, it can go 3 feet forward on its wings. This is abysmal. This is horrible. This is not a glide slope. It's actually approximating the aerodynamic behavior of a brick. In fact, bricks can and do fly better than the space shuttle. And if you were a crew member in the space shuttle and you endeavored to jump out of the space shuttle on its way down and you just like did spread eagle, the space shuttle would have time to land and your friends in the space shuttle would have time to go and get a feather mattress to catch you because you would be falling slower than the space shuttle. The space shuttle is also the fastest airplane landing in like history, at like over 200 miles an hour. It's ridiculous. Okay, I have to slow down on the space facts, otherwise we will never build this thing ever. So now we're doing the base, which is bag 2. Bag 2. All right, here we go. Yes, I'm an Android person. Android is wonderful. Android is great. Apple is not my favorite and not great. They make some good products. I like their laptops. I've been using a Mac Air for the last 9 years, and I'm really happy with it. But price comparison between commercial and experimental HPR motors. The commercial ones are going to be cheaper. If you don't already make motors, you will never save money by making your own motors. At best, you might get to fly more often, but you will never save money. Okay. Anyways, welcome to the live stream. I'm glad you could catch this one. What do I think about the future of hybrids on booster engine stages? Hybrids should die. Hybrids have no place anywhere. Kill them all. Make them go away. Quickly, please. Okay, a slightly more nuanced take. I don't think hybrids are particularly good for a lot of applications. I think Tori Bruno said it best, that one day hybrids will win in the trade study. But I like my addendum to that message, which is that you have to design the trade study for it to be a trade study that hybrids can win. Hybrids just, like, if you're in a situation where you can use valves, why aren't you using a liquid? If you're in a situation where you don't need the level of control provided by a liquid engine, why aren't you using a solid? Like, it's very, very rare that you need, like, the control of a liquid with solid propellants. In fact, I think maybe the best future use of a hybrid is like a weird like hybrid where you have two solid grains, one of which is like an oxygen candle, so you have like ammonium perchlorate, but you have a way to control whether the ammonium perchlorate is burning or not, and that produces hot oxidizer, which you then flow into like a normal hybrid motor. I think that would be like the only way I can think of to make a hybrid motor useful. I really don't like hybrids, if you couldn't tell. I built them before, and I don't like them. They're not good. Okay. Let's see. Let's see. Apple phones suck. I'm an Android person. Yes, happy to hear that. Okay, I'm gonna get back to building and check on the chat in like one bag of parts later. But there are 26 of us, which is good. Lots of fun people. I am not enjoying quarantine. I am way too much of an extrovert. So I am excited to be joined by many friends. So let's switch back to the workbench view. So we've got this base plate here that's going to hold everything up, and you need one of the 1x3 flat pieces. There we go. So this goes here. Can I? Stick with me here for a second, folks. I'm going to try adjusting the cameras live. I was so proud of this camera because you can see everything. But I think if I bring the camera down... Oh, I'm so sorry. That must look awful. I think this is probably a better view for you folks. Can you see a little better what's going on here now? Maybe tip it up just a little bit more. Yeah, that's kind of a better view. I think this will be more enjoyable for everyone. So we've got that. Next page. Cosmic exploration. You can do any grain geometry you could do on a hybrid and a solid, so why would you do it in a hybrid? I mean, I don't understand why people like hybrids. Like, maybe I'm missing something. Maybe I'm just being dumb and I'm missing out on the beauty and the purity of hybrid rocket motors. But I'm just not... If that's the case, everyone else is smarter than me. I don't like them. Can't figure them out. Okay, this and this. Now we need a 2x2, and it goes here, but it goes 2 off. Okay, that's sufficiently weird, but okay. 2 off on that one, and then that needs the 1x-whatevers. And there should be a 1 wide gap in the middle, which means I did it right. I just eyeballed that whole thing, but you could tell I did it right because we got the 1 wide gap and the 1 wide gap. So now we need these 2 pokey bits, which we have, and they are facing inwards. Ooh, this is going to be interesting. This is a fascinating. I'm already intrigued by where this is going. I missed some steps. There we go. Okay, so the long beam, which is this one, goes here, and then a 3x1 beam, which goes here. And then more of the pokey-outy clicky bits. That's the technical term. This is only to be referred to as a pokey-outy clicky bit. There we go. Point made. Yeah. There we go. So that's all put together. Now, those get capped off by these 4x1s. Yeah, like that. Okay. I don't know where this is going, but I'm excited to get there. I'm very intrigued. And then these little bits go on top. Oh, so I bet this is where like the name placard goes, and then there'll be like these beams sticking up like that. All right, let's see. Wow, oh, chat moved quickly. Okay. You'd be interested in seeing whether the storable nature of a solid grain with the control of valves would be beneficial. Mars injection burn or something if you don't want deathy hypergulls. So, Joey, the problem with that is that we've now developed energy management maneuvers, and energy management maneuvers let you do Mars injection with a solid without needing valves. Like, you just don't need the control. You do, like, a 4 meter a second trajectory correction maneuver a couple months on your way to Mars, and Bob's your uncle. You don't even need to worry about early shutdown because you can manage the energy adaptively with the onboard avionics system. Yeah, hybrids, I just can't, like, I think you would have to try, like, I think you would have to work hard to find a situation where hybrids would work well. And I don't think that, like, that's something that you need to work at. Like, you could just not work hard and use other motors that work well just intuitively. Okay, so this has the ribbing on the backside. So there's these weird textured bricks. It almost focused there. And I don't know why we're using the weird textured bricks, but the instructions say use the weird textured bricks along with the pokey-outy clicky bits. So we are using the weird textured bits with the pokey-outy clicky bits. And this will produce the results that LEGO has promised me if I just put them where LEGO tells me. This feels like excellent opportunity to say something like, "Wake up, sheeple," as I follow the instructions to the letter. But that's okay. Following recipes usually makes tastier food. I had some really good chicken soup for dinner today. It was just really tasty. Okay, so those are on now, and now, just like I suspected, we're going to stick these beams up. But first, we need to attach some, like, caps onto these parts I just installed, probably just to keep everything from falling apart. Those go like that, and then these 1x2 to 1s. Where do the 2 to 1s come from? Here's a 2 to 1, and here's a 2 to 1. So that one goes there, and then this one goes here. And then we get these like smooth top covers. I really like these pieces. They just feel very satisfying to push into place. No particularly good reason, just how smooth they are. They're just wonderful. You guys can't see anything. It's just a piece of black plastic tube, but I promise it's really satisfying to click them home. Okay. AMG Wagon, you're 16 and you've been serious about rocketry for a year now, and you regularly fly F-15s, and just got an RMS. Oh, F-15s, like the rocket motor F-15. You said you regularly fly F-15s, and I'm like, wow, a little young to be a fighter pilot, but that's cool. But no, you mean the motor F-15s. Awesome. And you just got a reloadable motor system. How long should I wait to go buy an L1 kit and do your attempt? Well, to be honest, I think that depends. If you can find someone to sponsor your junior L1 and you want to go get an L1 kit and fly it, totally you can. But I think both NAR will let you do a junior L1. AAA requires you to be 18, I think. I got my L1 right after I turned 18. So I don't think there's like any need for you to wait. Definitely, like if you're using commercial motors, even if you're making your own motors, if you're smart and well supervised, I think it's possible to do it safely. Let's see. Guero wants to know if anyone has complimented me on my wonderful haircut. And Guero, thank you. I appreciate that. No, people don't usually compliment me on my haircut. This is a hairstyle I have not worn for a long time. The last time I wore this hairstyle, it was a long time ago. I don't wear this hairstyle often. Usually I keep it a lot shorter. But quarantine is forcing us all to make sacrifices, one of which is that my hair is long, which is a maintenance nightmare, but apparently it is appreciated by my stream followers. Let's see. Is it possible to make a graphite rocket nozzle using only stepped drill bits? Hudson wants to know. Maybe. Depends on how much time you're willing to spend with sandpaper. You can make just about anything with sandpaper and elbow grease. That doesn't mean that it'll be a particularly good thing or it will happen particularly quickly, but you can still make just about anything. Okay. You'd suggest build... Oh, okay, that's for Hudson. So hybrid rockets suffer from their poor regression rates. I think a light just burned out on me. Their poor regression rates. So I mean, you could tune the regression rate, right? You can add material to your fuel grain. To accelerate it, you can decrease its density. You could give it some 3D structure. There's a lot of ways to improve the regression rates of hybrids. I just don't think they're that useful. This is a pretty good one. I will have to get another bottle of this. Okay. So now we're on to making these like feet thingamawhatsits. And so we need these 3x2s and then the right angle bits and then these smooth bits that go on top. And I think we need 2 of them. Yes, we need 2 of them. So another 3-piece, another right angle piece. I said another right angle piece. There we go. So we got 2 of them now, and they go like here and like here. Now I need these 2 2x2s, and they go on the front here, directly opposed to the bits I just added. And then there are these weird, oh wow, what are these pieces? I have never seen these pieces before. What are they having us do? These weird 3 to 2s? Yeah, Okay, guys, I built a lot of Lego pieces, and this is Lego kits, and this is the first time I've ever seen this Lego piece. I'm actually really excited. It's not every day you get to, like, see a new Lego piece for the first time. Okay. And then one of these little, like, gratings goes over the back one. And then I need to add some of these 3x2s, and they go in the front. Weird, so there's just this, like, one little 1-bit gap. I don't know why that's there, but it's just there. Okay. Okay. What do I think of rotation detonation engines, and are they the next generation engines? Or will they be more of a niche technology? That's a really good question. Actually, to be honest, I can't answer that off the top of my head. You can get 15, 17% efficiency off of an RDE, a rotating detonation engine, because the detonation wave is more efficient than a deflagration that normal rocket engines use to combust the propellants. That comes at a complexity cost, so the engine will be heavier than a given deflagration-based engine. It just kind of depends. There's a lot of really cool research going on into them right now. Purdue is doing some awesome work, and I think the University of South Florida, maybe University of Central Florida, one of the Florida universities also just did a really cool engine. Although, I think they might have been bragging a little too hard. They said it's like first hydrogen-oxygen RDE. But like when you look at it, their hydrogen was like 40% methane, which stabilizes the detonation wave. So they were upselling a little bit. But you know, that's how research always goes. You're like, I've solved all the problems. And what you really need to say is I have solved one of the hard problems and made it vaguely more feasible to do this thing that I was trying to do. Okay, is Tripoli or NAR better? Tripoli lets you do experimental motors. I found NAR to be a little more approachable. 6 of one, half dozen of the other. I'm a member of both. Okay. The trick is, if you join Tripoli, get your L3 and then join NAR at least once. That way, if you ever let your membership lapse, NAR will keep it active for you, and you can go and re-up your Tripoli membership and keep your L3 certification. Okay, Cosmic Exploration says his nearest clubs are 2 hours away, and to that I say you are lucky. I usually had to drive much farther than that. Even in Kansas, my nearest club was 3.5 hours away. It was a really good club, but it was still pretty far away. Paul says he's having a mental breakdown on his homework. If you want to transform a normal vector in a homogeneous coordinate system, do I only have to multiply it with the inverse of the transformation matrix? So Paul, what you're trying to do is, so when you say transform, are you saying you have 2 coordinate systems and you're trying to move a vector around in them? Can you be a little more specific about what you're trying to do? I think if your transformation vector is a matrix, you should be able to do it just with the inverse of the vector. I don't think there's any bigger trick to it, but I don't want to say that off the top of my head without knowing exactly what problem you're trying to solve. So we should get back to building this now, or I will be here till the end of time. This piece goes here. Oh, and then I got the that little hole I was showing off earlier. It's having us put a piece right there. Fixed it. How about it? Okay, and then 2 of these black caps that go over the top. That one and that one. That did not bring joy. That was hard to put down. Okay, now we need the light gray piece that clicks in here. That goes like that. And then we get this ISS decal, and we put it there and tip it down. Oh, wow, that looks so good. I love it. Check it out. It says, like, space station and everything. It's not going to focus. This webcam, I need to get a different webcam. It's not making me happy. It is, in fact, making me sad. All right. Has anyone noticed that newer generations are getting smarter? This is actually a really fascinating phenomenon. IT test scores go up by like 9 points every 20 years, like clockwork. They just keep going up, even when they adjust for like education and other things. So no, it's absolutely a thing. The fact that you can get by on the accumulated wisdom of like decades and centuries and millennia of humans who lived before you is like a huge deal. Like we had to invent language. Like there were some things we couldn't think about until we had invented language. How crazy is that? Like the scientific method, it's only like 400 years old. How huge is that? And like you can use it to just like solve everyday problems. It's awesome. Of course, new generations are getting smarter. And the problem with that is that I'm going to be stupid here in a few years. But that's okay, because there will be someone new who is smart, who solves problems, while I retire, hopefully to like a tropical island somewhere. Okay, so is more methane better for RDEs? It depends what you're trying to do, but specifically for hydrogen, oxygen RDEs, more methane is better. Do RDEs impart weird angular momentum effects a la Falcon 9 Flight 1? Huh. I don't know. That's a good question, Joey. I don't necessarily think they do, because you don't, like, the rotating part of rotating detonation engine is because the wave propagates around this annular cavity. There's nothing actually rotating. And you have to propagate the wave, otherwise it'll transition to a deflagration mode. But I can totally see how maybe if you set it up weird, you could get like weird angular momentum effects. But I also kind of have like a weird nagging sense that if you set up the throat to have choked flow, it shouldn't matter. I don't know. I think you'd have to do some analysis. Michael Moseri wants to know my thoughts on the new Crew Dragon docking sim. I was disappointed it's a Cartesian sim. It's really cool. The GUI is beautiful. I missed seeing beautiful SpaceX GUIs in my life. But I wish it had accurate Closey-Wiltshire dynamics. So I'm making my own. Stay tuned for that. We'll see if that ever actually happens. I've got the ISS model loaded and the Dragon model loaded and everything moves, but I just need to make it pretty now and then find a way to package it. Maybe I'll put it on Steam. Who knows? Okay. You can buy hexa was Melena. I have no idea what that chemical is, but it sounds scary. If you buy it, good luck to you. What is the biggest rocket I've launched? Michael Ding wants to know. I launched a couple of P-motor powered sounding rockets, and, you know, 12 Falcon 9s. So I had a big job to do on the little rockets and a little job to do on the big rockets, which is usually how it works. Welcome, Thorgon. Yes, adult drink and Legos. It is like every child's dream come true. You get to slightly mentally impair yourself and play with Legos. It's awesome. Okay, so I have to put this together, and frankly, this is going to involve hole counting, which feels like a thing I maybe should have done before the wine. But here we are, and so here we must stay. So it looks like this is just in the middle, which is roughly there. And then these are the small ones, and they go on the backside, one apart. Let's just check real quick. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Counting is hard, but I've successfully managed it. Okay, so now we've got these things sticking up like that, and then with these 2 blue buttons on the back. And then just outside of them go these weird, like, T-piece adapters. And then we flip it around and get the second one, and it goes there, like that. So we've got these T-pieces back here. You can't see that at all. T-pieces back here, and then the second bar there. Michael Moresi. Yes, you are absolutely right. We do not have to waste any time hunting and gathering. And this is really funny because after all the wonderful benefits society gets from having specialization of labor, I actually feel really strongly about like learning as many specializations as I can. Like essentially, I want to be the ultimate zombie apocalypse Go team member. I want to know how to like build a radio from scraps. I want to know how to like refine my own metal, start my own machine shop. Like all those things just strike me as like super important. Like what happens if you know, you can't rebuild civilization from scratch and something bad happens. I mean, also, you know, ultimately, I'm hoping that nothing bad happens and I can use those skills to go to Mars and do cool stuff on Mars. But yeah, it's just so awesome that like we have all this specialization, and despite all this specialization letting me do what I love, which is build rockets, something I really long to do is to like see behind all the specialization and like see how things are like done by like the experts who do it on a day-to-day basis. Okay. I have no idea what this part I'm putting together is, but I'm just following the instructions now. I feel like the odds of us building the spacecraft in the order specified by the build sequence is probably increasing, and the chances of building it in the order that NASA assembled it in are probably decreasing. Okay. So I think that matches. That's like more or less correct. We'll find out if something doesn't fit later. So this piece goes here, and this piece goes here. And I need 2 of these squares that go on the back edges. And then 4 of these, and they go like this. And then 2 more squares just to top it off. Very structural. Okay. Matt Martinez says he's super hyped to join tonight, and he just finished your last assignment for the school year, and you're hoping that the senior year of aerospace engineering is a little easier. Congratulations, Matt. Welcome to the stream. I found my senior year much easier than my junior year. My junior year was hell. Junior year was hard. I was the president of the rocket team, and I had to take the hardest classes. That was rough. Oh yeah, and the lab caught fire. Joey Murphy in the chat was my safety officer for the rocket team when that happened, and that was a lot of meetings. Holy cow. That was not fun. Okay. Hey, welcome to the stream, Daco. Joey says that he hopes the actual Dragon firmware has the actual Kalesi wheelchair. Yes, I do as well. And yes, 07 was a drag. But I think Miller's at the Aerospace Corporation now, so now it's just Widnall, who is sometimes awesome and sometimes not. Michael wants to know why all the space channels drink alcohol midstream. The answer is really actually quite obvious. It's because it's rocket fuel. Okay, got to keep putting this together. So this is like this, which is correct. So now we get to turn the page. These gratings go here, and then 2 more of the blue through pieces. And they stick out this side. And then you turn it around to this side. Oh. Okay, check this out. This is really cool, guys. This is awesome. This drops in right here. And then, watch this. You just push these through, and it grabs it. Oh, wow, that is so awesome. Guys, the people at LEGO who figured this out are awesome. That was so cool. It fits, and it's like strong. Okay, it's not so great in torsion, but it is still pretty strong. That was awesome. Guys, holy cow, that was so cool. All right, now that we've got that done, these blue pieces go here. And these pieces go here. Broke that. Okay, there we go. Alright, wow, chat moved quickly. Okay. It seems weird to see Tory Bruno tweet the phrase Falcon 9 Heavy to refer to Falcon Heavy. It's never been called Falcon 9 Heavy. It does not have 9 engines. So the SpaceX naming scheme is just absolutely garbage. Like, you could call the Falcon Heavy Falcon 27, and it would make sense, but that's not what we do. So, but we knew what Tory was talking about, so he gets a pass. If civilization collapsed right now and it doesn't rebuild in 1,000 years, Harry Seldon films. I don't understand that reference. Sorry. Okay. Falcon 9 is still the name of the rocket. The Delta IV Heavy is just 3 Delta 4s. I like SpaceX. Delta 4 is weird. The CCB is awesome. The DCSS is amazing. Holy cow, that second stage. But I don't know why the whole rocket is so expensive. It really just doesn't need to be. I guess, I don't know, maybe it's just because it's hydrogen, so you need more aluminum for it, but it's just an expensive rocket. I will say, the Delta II has the advantage of having the prettiest paint scheme of any rocket. I love the Falcon 9's paint scheme. That blue Delta II, that is how you do it. Okay, so now we get these two, and they go here and here. Okay, so with that connected, we need to do this piece with 2 of these bars on it, these gratings. What do you call these pieces with the like little spaces between them? I call them gratings, maybe? You guys know what I'm talking about. So they go there, and then this goes on top right here. And this whole piece just looks awesome. And I built none of the space station, and I already love it. But my wine glass is empty, so we're going to fix that. Colin Burfeld, I read on the wiki that I did debate in high school. What are my thoughts on the different categories? What wiki did you read that on? I mean, you're right, I did debate in high school. I did a lot of debate in high school. I was pretty good at it, but you read on the wiki. Yeah, I did. That's so cool. I don't know where I said I did debate, but I did policy debate, and I love policy. Holy cow. LD is fun. Forum, I'm not a big fan of, but holy cow, policy is fun. I love policy. My colleague was my sister, and we just mopped the floor with everyone. Almost everyone. There were a few teams that were pretty good, but we won. We almost won state our sophomore and junior years, and I think we're undefeated the entire senior year of my senior year. It was a lot of fun. It really helps your thought processes. I can take notes really quickly because of it, and I speak way too fast because of it. I get comments on like every YouTube video I do that like you should talk slower, and I'm very sorry. I know I talk quickly. That's what I can do. Okay. Joey is right that the lab catching on fire was a safety aberration and not the norm. The lab fire was a result of an electrical fault. It had nothing to do with rocket engines. Just bad luck. The lab was an old welding shop, and then we proceeded to put into it several other pieces of interesting equipment, namely a oven for curing high-temperature composites. And the electrical equipment is what had a problem, not the rocket engines. Let's see. Carly, is Formula SAE worth it? Formula SAE is awesome, and I tell you what, at MIT, the Formula team was even better than the rocket team. And I'm biased, I love the rocket team, but holy cow, the Formula team, their level of professionalism and competency set a bar. And partly that was because they had interviews. You had to interview to get placed on the team, so they wouldn't let everyone on the team. So they had very, very good freshmen that they trained to be very good sophomores, and by senior year they were just incredible engineers. And Rocket Team took everybody, which is not to say that they were bad, just that like you know, sometimes you had to spend more time training people than like people who joined FSAE and were already like excellent machinists. But yeah, holy cow, if you've got a good FSAE team, I knew SpaceX would recruit from FSAE teams more than rocket teams, which seemed weird to me. I think it was probably just because most FSAE teams are older. College rocketry is a relatively new phenomenon. Okay, let's see. What college did I go to, Michael? MIT. Let's see. Chad. Kenji, the time when Atlas V Heavy was planned was before ULA was formed, back when it was Lockheed Martin and Boeing. And then Boeing committed, you know, some minor corporate espionage, and then, you know, did some slightly illegal political maneuvering, and then when the courts found out and threatened to sue them into oblivion, Boeing was suddenly very excited about forming a joint venture with Lockheed Martin. And since they had Delta IV Heavy, they didn't need Atlas V Heavy. Okay. Everyone here should read the Foundation. Yeah, the Foundation series is excellent. It was the MIT rocket team wiki you found it on. You do Lincoln Douglas, same talking speed tendencies, undefeated as insane. Well, Colin, I had the advantage of having an incredible partner. My sister put in a lot of work, and she was an incredible speaker. She did the first AC and this first NC, which made it much easier to win, and she gave an incredible 1AC. We also always ran our own cases, and it's pretty hard to lose if you write your own case well. Yeah, okay. I guess I must say it's somewhere on the MIT Rocket Team wiki. I have no idea where I put that. I wrote a lot of the MIT Rocket Team wiki. Hopefully there are new people writing it now, but I was really excited about documenting everything. You're a junior in high school and you've been trying for aerospace with a pretty average GPA. What's the best college in the Northeast to go to for a job at SpaceX ULA? SpaceX recruited pretty hard from MIT. They recruited pretty hard from Cornell. BU, Boston University, has a great rocket team that gets recruited from a lot. I know a lot of the launch team in Florida is from BU. Yeah, whatever one you like. I mean, you need to succeed and excel in college to get a job at SpaceX. So pick one you'll succeed and excel at. Okay, what are my thoughts on hybrid engines? Nicolo, I hate them. They should die. Hybrid engines do not belong anywhere in the rocketry field. I mean that mostly tongue-in-cheek, but only mostly. If you can find a good use for a hybrid engine, use a hybrid engine. But just most of the time, they're just not as useful as a liquid or a solid. Okay, I need to actually start putting pieces together or we will never be done with this. We are an hour into this stream, so thank you for joining me for this hour-long stream so far. There are 41 of you spending your evening with me, and that warms my heart. But we do need to actually, build the space station. Otherwise, we'll be just like NASA, and we'll spend a decade building a space station. And frankly, I don't have a decade to spend building a space station. I have other things to do. Okay, so we got that, and then we need these white bars up at the top, and then these light gray. Does anyone know what purpose these parts serve? These like rounded corner ones, because they look cool. I just haven't used them a lot before in LEGO kits, and it doesn't strike me that they like have an aesthetic purpose. Do they have a technical purpose? Do they like fit together differently? I don't know. So now we do a dark gray piece. And then these pieces, which go here. And I think I need one more of them. Yeah, here. Oh wow, there are a lot of pieces in this step. Goodness gracious, holy cow. So white goes to the left, and then it goes gold piece, gray clicky piece, gold piece, white clevis piece, I guess, something like that. Gold piece, gray clicky piece again, gold piece, two studs of nothing, And then it's going to go gold piece, gray clicky piece, gold piece, white clevis piece, gold piece, gray clicky piece, gold piece. Except I did that wrong. Fascinating. How did I do that wrong? So I needed a gold piece there, and then another gold piece. All right. And then I think it just needs 2 white bars on the back. Yep, exactamundo. Perfect. Okay, so we got that sorted. Let's see. What do I think of aerospace at Purdue? Purdue is one of the best aerospace schools in the country. It is incredible and excellent, and if you want to build rocket engines, Purdue is a great school to go to. Hey man, you can always improve your GPA. Work hard. Okay. Joey Murphy, I was one of Charlie's classmates, and I can tell you MIT doesn't just care about grades. They care if you're interesting. Yes. The problem with MIT is that they could put together a class every year of just 4.0 GPAs and still have a lot of 4.0 GPAs left. So MIT first asks if you're capable of doing the schoolwork, and then secondly asks if you have an interesting perspective to share with your classmates. And for the life of me, I'm not sure why they thought I had an interesting perspective to share, but I was very grateful they let me in, and whichever admissions officer made that particular mistake, I was eternally grateful to and made the most of it. Okay, so this goes here, and then these white 4x1s go next in. I swear there's got to be one more. Okay, well now we're lowering pieces by necessity because I can't find a piece. This should be like a really obvious piece, right? Like this isn't a hard piece to find. Oh, here it is. Okay, so that piece, and then a white bar goes in the middle, so it's going to be one of the short ones. And then it's got 2 more short white bars that go up to those edges. Oh, okay, that's clever. I like that. That's very strong. And then we come over here where this piece goes in the middle. And then another one of these weird gray oval pieces. And then like a bunch of white cladding. There we go. So this goes here. And this goes here. And then these go on the edges, and then a 1x1. Sorry, I keep kneeing the camera. I will stop doing that. All right. The rounded corner parts are the top part of the Lego on both sides. So how normal Lego have a pattern for the bottom and one for the top, these have one for the top on both sides. Oh, fascinating. That's really cool. 0.5 GPA and so good at MIT if they have a history of projects, volunteering, etc. Yeah. Okay. I will add on to Joey's message, which is very correct, by the way, and say that anyone who could succeed at MIT can succeed anywhere without MIT. MIT is really just volunteering to do a lot of extra hard work, and for people who are already able and willing to do the hard work, it's super valuable because they can succeed to their fullest potential. But if you're willing to do the work at MIT, if you're willing to be a self-starter places other than MIT, you can be very successful there as well. Okay, this is kind of weird. I have to spend a second figuring out what they're doing. So it goes like that, I think. Okay, so there's some offset pieces, and the instructions don't make it super clear. I can't tell if that's an empty space or a full space. But I think what happens is we go like this. Yeah, okay, so that's right. And then that one gets this piece like that. Okay, I think I did that right. Can people tell? Did I do that right? I think the instructions don't make it super clear, but it like looks to me like it's sort of correct. So we're gonna keep going. So then I need 1, 2. I said I was gonna stop doing that, and I didn't. I'm sorry, I lied. 1, 2, 3, 4, 5. So we need 5 of these pieces. 2, 3, 4, and 5. And it fits perfectly, so that means I did it right. Yay! I did it right. I'm not a total screw up. 2, and then 3. So this is weird and asymmetric, but cool. I mean, real things in real life are not always symmetrical, but Legos are usually kind of symmetric. But we are venturing into the realm of asymmetry, so let us boldly go where no Lego builder has gone before and follow the instructions. I know, such a brave thing to do, right? This piece goes up and faces back. Okay. Oh, and then these gray bars, I need 2 of them. They go down the middle. And then these pieces go on the back side. Oh, this is so crazy. We turned like a 2-piece thing into like a 3-piece thing, and it's awesome. This is so cool. I love everything about this kit already. It is just super exciting. But I did something wrong. Yes, I see exactly what I did wrong. I have missed some of these gold studs. I think the light above me is dying. It just suddenly gets darker when it feels like it from time to time. I can't use that. Can I use it here? There we go. Okay. Let's try counting again, Charlie. But this time, add 1. Science! I did it right this time, because it's got a gold stud in it now, which means I did it right, because science. In the famous words of Mark Watney, oh wait, I don't want to get demonetized. In the famous words of Mark Watney, I have to science the something out of this. Okay, so that's taken care of. And turn the page. So this looks like this, and we have to build these weird Scooby-Doo pieces. So that goes up like that, but there's 4 of them on each, so 8 total. 1, and 2. And then inside of these go 2 bright orange widgets. I don't know why they're bright orange, but they're bright orange. Do I have another 2 bright orange ones? I do not, because only 1 goes in each one. If I could follow instructions, that would have been obvious to me. One and 2, and then these like side pieces go on the bottom. Weird. Okay, cool, but weird. There's 1, and this will be 2. Two. Awesome. And then these go on the ends, right here. Did I do that right? I think I did. Right here. Okay, so with that done, you flip this whole thing over, and you have to add a whole bunch of these white edging pieces. And 2 gold dots. I'm going to start with the gold dots, because otherwise I will forget them. 1 and 2. And then we need 4 on this side. 2, 3, and 4. And then I need 4 on this side. Okay. And while I've been building up this truss, I have been woefully neglectful of the chat, so we will take this opportunity to continue being woefully neglectful of the chat and instead add some more pieces. See, like what I did there? I propagated an error. I normalized deviancy, which is a real technical term. When you normalize deviance, you are allowing it to become acceptable to have off-nominal conditions, and this is a directly contributing factor to several NASA mission failures. So never normalize deviance, and always check the chat. Let's see, Ismail Hosam, what do I think of the concept of a raccoon? Raccoons are worse than hybrids. In order to get a large enough rocket up high enough that it would be useful, you have to build a balloon that is much larger than the rocket you would need. So why bother? Just build a bigger rocket. Plus, if you're building a rocket to go to space, you already know how to build a rocket. And you don't already know how to build a balloon necessarily. So you could save a lot of time and effort just by using rockets. Okay, is it possible to get a job at an aerospace company if you don't go to an MIT or an MIT-like school? Absolutely. Most aerospace companies hire not MIT people. MIT only graduates about 30 aerospace engineers a year, and there's like 200 to 400,000 aerospace engineers in the United States alone. So certainly, there are a lot of non-MIT aerospace engineers. Okay, to the high schoolers out there, you should not be doing something just because it is enough to get into a school. Yeah, I mean, do stuff because you like doing it, and then you'll get into a school that is a good fit for you, as opposed to doing it because you want to get into a school that then may not be a good fit for you because you were just doing it to get into the school. Okay. Nicolo Martinez, do I think it would be possible to create a small rocket that could fly up 200 kilometers and come back and land propulsively using 3 hybrid engines? Nicolo, that question is like so specific. Like, you could design a 3 hybrid engine powered rocket that could do that. It wouldn't be very small. It would weigh several hundred pounds. It would be probably $100,000 worth of parts, but you could do that. Should you do that? Probably not. I can think of several better ways to do that. If you want it to land, you should almost certainly use a liquid. It'd be higher performance. It'd probably be a smaller rocket. It would probably even be cheaper. Okay. Am I really from Kansas? Yes, I am from a small town in Kansas called Hutchinson. It's about 45 minutes northwest of Wichita, and it has a space museum. It's a pretty cool town. It's a pretty small town, but it's a nice town. Let's see. Aerospace internships idea, Hudson asks. Email everyone. That's what I did. My first summer, I actually ended up working at MIT for the summer at Lincoln Labs, doing research on long-burning solid rocket motors. It was a really cool project. And the friends I made at that job helped me get my first job at SpaceX. It was very awesome of them. Okay, got that. Got that. Next page. I tell you what I am going to do. I'm going to take a quick break to mess with the air conditioning system in this apartment because I turned it up really high because my computer was making everything warm, but then the sun went down and it is no longer very warm. So I'll be back with you in just a moment. I tell you what, it was surprisingly challenging to get that air conditioning system to turn off, but I have prevailed. And now we have a main ISS truss we need to prevail upon. So we've got this, and we have to flip it over again, and we have to add these 2 white beams. And they go here, into from the edge. So I think this is the ISS main truss, or at least a part of it, which runs the length of the station that holds the solar arrays. So once those are on, we need the gray pieces. I think those are those, but I can't be sure. The color is just a little bit funny. And they get these weird edge pieces. Cool pieces, but weird pieces. Whoop, I just broke it. Well done, Charlie, well done. Okay, so now we need these 3 smooth, slick, shiny pieces, and they go 1 in the middle, and then in the middle of these 4x4 pieces, which is there and there. And then we've got these 2 pieces. Oh, clever, clever. And so see, now you're completing this gray panel on each of these sides to give you a spot to attach everything. Oh, that's bravo, well done. I love seeing how clever you can put some of these pieces together. Okay, so once you've got that done, then we have to put these pieces on the edges. Just like we did on the bottom ones. I wonder if LEGO like specifically plans these kits out so that you get like an endorphin rush on like just certain sections of it. 'Cause there are just like some parts to do that are just incredibly satisfying, where you can like where either you don't see it coming and then all of a sudden you're really excited because you see they did something really smart, or you can like see it coming and when you finally get to put it together, you're just like, yes, I have completed it. Okay, so now we get these big gray panels and they just drop down in here. Yep, like that. And that holds everything together. Wonderful. Okay, and now we need to put like a bunch of white paneling on various places. That is not where that goes. Where did these little panel pieces go? So that's like that. Oh, they go down here. Okay. So these pieces go facing upwards down here. And that'll be where the solar panels attach. Oh no, these will be where the radiators attach. Okay. I was almost smart there for a second, but then I forgot and was stupid. Okay. So once all of those are squared away, we take these gold... Oh, nope, I was wrong again. It is in fact not the radiators. It's these like gold rods that drop down into those slots. So you've got a slot here, and you take a gold rod, and it goes like that. Cool. Awesome. And that one goes there. That's like some really nice detail. I like it. Me gusta. All right, back to the chat. What's the best internship that would take high school students? Right now, it's kind of a tough situation. I knew high schoolers who worked at SpaceX. So, I mean, work hard, demonstrate your competence, step up and get hired. Okay. Any suggestions for learning aerospace engineering for someone who has struggled with a normal college education? Neutronium. Absolutely. Do hands-on things. Build stuff. Put things together. This has 2 advantages. One, you learn it in the best, most useful way possible. And 2, you gain technician skills, and technicians are frequently paid as good as engineers, and they get to do all the fun stuff because they get to put stuff together. The downside is you have to sometimes put up with engineers telling you how to do stuff when engineers are stupid. But yeah, definitely like a technical education. If you want to learn, like, say, to be an A&P, an airframe and power plant technician, those get hired by like every space company everywhere. And actually, Agile is hiring one of those right now. So if you're an airframe and power plant technician, or just a skilled technician who knows how to work with rocket engines, you should go to agile.space and apply. Wow, thank you, Anchovy. Not only should I get a telescope, I have a telescope. I have a very nice telescope. Actually, I will take this opportunity. Let's see. I am a pretty dab hand with my telescope. I will see if I can show you some pictures from my telescope. Let's see, I'm gonna have to get it off of my spare drive. See, this is exactly how distractible I am. Let's see, so I should be able to go to this image, and I should be able to add an image, and if I create a new one, and I call it Jupiter, and I browse for it, I should be able to find it on my desktop, which is there. Check this out, guys. So this is a picture of Jupiter that I took in January of 2015, 5 years ago now. Holy cow. So I took this image, it's upside down and flip-flopped. This is one of the first pictures I took through my new telescope. I got a new telescope in 2015. It's a Celestron refractor. It's 6 inches in aperture, and it has a focal length of 1.6 meters. I have a planetary imaging scope for it, and I have a Malin cam for it for doing deep sky observing. And I love it. It is amazing. And I just took it out the other evening. I got it set up here for the first time in Colorado. And so this image was taken, important caveat, at opposition. So this is the closest Jupiter will come to the Earth in our orbits. And the opposition in 2015 was one of the best oppositions that's going to happen for like hundreds of years. I also got to see Comet Lovejoy. I don't know if I have any good pictures of Comet Lovejoy on this hard drive, but yeah, it was a ton of fun. So this is called lucky imaging. So what you do to take a picture like this is you set the telescope up, you point it at Jupiter, and you have it automatically track Jupiter, and you take one picture that lasts 1/100th of a second every 100th of a second. So you're essentially taking like a super high-speed video. And then you have computer software, and the computer software analyzes each picture to see if any of the pictures are blurry or fuzzy, or if the atmosphere got in the way, or if there was a raindrop, or any of that nonsense. And it will throw out all the bad pictures, and then it will look through all the remaining pictures and find the clearest parts of the best pictures to stitch together to take this picture. So this one picture is a composite of over 9,000 pictures that I took over the course of about 3 days while Jupiter was in opposition. You have to be careful because, you know, Jupiter rotates, so you have to take them at different times each night so they all line up. Okay. Anchovy. Oh, yeah, Starlink is super cool to see. I really like to go out and see satellite passes. ISS is also super cool. Okay. Cosmic, thank you. I really love my telescope. I have a nicer telescope than I have car, which speaks to my priorities in life. Okay, what software did I use to process this image? This image was processed using Registack 6 and AstroPi. Oh, and Photoshop, obviously. It feels kind of cheesy to say that because I'm like, oh, you photoshopped this picture of Jupiter, but like you just use Photoshop to like play with the color levels and bring out detail that's kind of hard to find. You do wavelet processing in Registacks. This telescope is called the Celestron C6R. Okay. Cosmic, I think I can only see the 4 moons of Jupiter. I don't think I can see any more than 4. I haven't tried, to be honest, though. Maybe I should give it a look-see. Okay, I'm really going to get none of this done if I do not continue opening bags. So I need bag number 4 now. I think we've all just decided that the correct order of assembly has gone out the window. So we will take our space shuttle, and I'm sorry, space shuttle, but you've been superseded by this new technology called single night to orbit, where you build an entire space station in a single evening, but then you don't actually launch it. It's a lot easier than doing actual space stations. Okay. So, we've got all of that sorted. What's everyone else doing this evening? Anyone else got their telescopes out? Does anyone else here have a telescope? Or is everyone else building Legos, or just procrastinating P-sets and exams they're about to take? I asked this question once, but there were only like 19 people on the stream the last time I asked it, so we've got like a whole twice as many people to ask. Michael Moresi, I have been a manufacturing engineer and a launch engineer at SpaceX. Michael, there are a few more than 3 spacesuits at the moment, but not all of them are on the space station, so they can only use some parts. I think if I recall correctly, there's either 7 or 11. But yeah, all the EVA suits are left over from the Shuttle program. They're all really old. We do need to do another production run of spacesuits soon. Nicolo, how small can I get a working liquid engine? Well, the smallest liquid engine I've built in my life was a 28 Newton or 7-pound thruster. The job I am working for builds all kinds of thrusters in that thrust range, larger and smaller. You can build bigger engines. The liquid rocket engine I'm building on YouTube has 6 kilonewtons of thrust. So it's a relatively large engine. Okay, yeah, there's a lot of options when it comes to building liquid engines. So I think this is kind of an interesting piece. This is another new piece I've never seen. Oh, I have to switch to the workbench view. This is another interesting piece that I've never seen before, is this one right here. But it wants me to take this piece and stack 2 bits on top of it, back to back, with the long edge of the piece parallel to the axes of the hole. It looks like we're going to build Dexter, probably. Oh no, this is Kaibo, Columbus, and Destiny. So these are the 3 modules of the space station. Okay, here we go. All right, so then we need a circular piece with a single dot, and then we need one of these black pieces. So these black pieces are the berthing to docking adapters that let the Russian spacecraft dock, well, I guess, and also the commercial crew vehicle piece. It's now the international docking standard. As opposed to berthing, where you use the robotic arm to connect the module up. Okay, so this is like this, and we need the dots. What do the dots look like? It's got to be really embarrassing for me to be live on the internet and like failing at finding like easy to find pieces. This looks like a soda can top. I don't know what they think it's supposed to be. Maybe an antenna? Might be supposed to be an antenna. Okay, so we've got both of those on. Let's see how long it takes me to figure out what this is supposed to be. So we've got these, and then these fold back flat. Okay, weird. That's not what I would have expected to do with those pieces, but okay. And then I take this piece, and it goes there, and I have to slide this yellow axle through it. Nope, no I don't. I have to read the instructions. Read the instructions, Charlie, and you will see how to do this correctly. So one of these gray discs, followed by a light gray disc, followed by another dark gray disc. And then it needs one of these white smooth pieces, and then a different white smooth piece. I have no idea what part of the space station this is, so it's going to surprise me when I figure it out. Can anyone tell what this part of the space station is going to be before I figure it out? Give me your guesses in the chat. Joey, if you ever want to swap telescope notes, you should shoot me a text. We can find a time to go stargazing. Let's see. Yucca, SolidWorks is a super useful piece of software, and knowing it will definitely help you get all kinds of jobs everywhere. Anchovy, any telescope you get for cheap is a good telescope. You saved it from someone who would have used it for ill, probably. Reed, you enjoy the videos, especially the liquid rocket engine series. You're designing your own liquid rocket engine. Oh, that's super cool. I wish you the best of luck on it. Be safe. Remember, you can get hurt doing rockets. I feel like people forget that like too often, which is that like they will blow up on you. And I don't know how many patrons are here in the chat. Patrons can't say anything, but I'm allowed to say things. I am working on another project right now. It's another liquid rocket engine. It is going to be done sooner than the big liquid rocket engine. And it is reminding me exactly why rocket engines are dangerous. I'm rediscovering a lot of ways to possibly hurt yourself with liquid rocket engines. Okay. Oh, I tell you what, I bet this is the Russian segment. And this is how it connects to the Z1 truss right here. So this will connect here. I guarantee it. That's going to go right there. Yeah, so then this is the Russian part, and this is the US segment. So this is Unity, and this is Zarya. Zarya means sunrise in Russian. Funny story about Zarya, it's actually a US-owned module that was built in Russia. And they did this so that the Russian aerospace engineers would stay employed and not go work for North Korea or Iran or other countries that may have nefarious intentions. So the US very, very deliberately, essentially like paid a ton of money to keep the entire Russian aerospace sector employed at the collapse of the Soviet Union so that weapons of mass destruction wouldn't propagate, which was, frankly, very clever and a very good deal. It was very intelligent of the United States to do that. Okay, so now we have to get one of these, and another dark gray piece. Yucca, no, the 7-pound thruster was a ethanol gaseous oxygen engine. I called it the desk engine. I built it with another grad student at MIT. Yeah, Joey, I think you could call an electrospray thruster a liquid rocket engine. I mean, it's not a combustion liquid rocket engine, but it's still a liquid. Would an ablative 3D printed plastic nozzle be a viable topic to experiment with in high school? To be honest, not really. I've made 3D printed rocket engines before out of plastic. Torrey Bruno blew one of them up for me. Very kind of him. But the answer that I discovered was that they're like mostly garbage and not worth the trouble. I mean, if you want to do research with them just for the sake of saying they're garbage, I guess go for it, but be safe. Plastic's a brittle material. It'll throw shrapnel if you break it. So you got to be aware that if it breaks, it could hurt you. So do I think they're like useful? Not particularly, but I guess you could if you have access to all the test facilities you need to work with them. Okay, so we've got this, and now we need to build. So this is the logistics module. So the Japanese logistics module is kind of permanently mounted on top of Kaibo. Kaibo is the Japanese experiment module, and the single largest piece of the space station, by the way, in case you were curious. There were supposed to be a few larger segments built by the US, but I think they all got procrastinated. The US actually bought one of the other modules that Japan was supposed to build. I think it was the centrifuge module. The US traded Japan. The US gave Japan a free launch, and Japan gave the United States this module that they'd half built. And then the US like utterly failed to finish building it, which is kind of sad. It'd be really cool to have a centrifuge up on the space station. So this little bit that I'm building right here, this is the external experiment platform. So it's got a little robotic arm, it's got a tiny airlock. They deploy a bunch of CubeSats out of this airlock, and eventually they're going to use the NanoRacks airlock. But Joey would be the person to ask about that instead of me. I don't actually know what the status of the NanoRacks airlock is. So it's got that, and then we need this like little piece here. Is that what they're talking about? I don't think so. I can't tell what this piece is. But I assume it's none of these three pieces. Or that piece. Ah, it's this one right here. Haha, I have discovered it. It is discovered. There we go. Okay. So this is Kaibo. This is the single largest piece of the space station. Well, this piece is. This was launched on a separate shuttle mission, and this was launched on a separate shuttle mission. Okay, Michael Rest wants to know about the Chinese Space Agency guy. Oh, you are the Chinese Space Agency. They're the only ones that innovate that isn't SpaceX. I'm not sure I agree with that statement. Yeah, I actually strongly disagree with that statement. The U.S. is flying all kinds of cool stuff on the Perseverance rover. It's got the space helicopter. How is that not innovating? That's so cool. There's a helicopter on Mars. Well, there will be a helicopter on Mars if it doesn't crash. That's so cool. Problem with SolidWorks is that it's not free. Sleep Dog, you are correct. It is like $4,000 a year. It is really expensive. If you wonder where your money goes, your ad revenue from this stream, $4,000 of it a year goes to SolidWorks. Okay. Hypergonics. Nope, it was ethanol Gox. Modern propellants can be scary. Modern propellants can be very, very, very scary. I would know for a variety of reasons. Patrons don't say anything. Yes, modern propellants are scary. What are interviews like at SpaceX? I hear they are stressful. I really enjoy interviews. I find technical interviews to be a ton of fun. You get to meet new people, and like, if you don't get the job, so what? You didn't get the job. It's like, just kind of like you're talking to other people for the fun of it. So I never found the interviews to be particularly stressful, but I can kind of see how they would be. I got really lucky. I absolutely nailed my first SpaceX interview. Okay, I have to tell the story. I haven't told this story before, so this is going to be a story to tell. So my sophomore year of college, when I was about to get my first internship at SpaceX, I had a serious medical health issue where I was sent to the emergency room and hospitalized for a while, and then I spent several weeks on bed rest. And while I was on several weeks of bed rest, I had to take painkillers, and not like low-key painkillers, like opioid painkillers, like the real stuff. And I had a SpaceX technical interview scheduled for the 4th day of my opioid painkiller regime. So I did my first SpaceX interview on serious drugs, like, whoo! I was out of it. And they asked me like a bunch of deep technical questions, and I just was apparently really lucid and lucky because I knew the answers down pat and I gave good answers, and they hired me. And then when I got to my first day at SpaceX, my boss was interviewing me. He was like, yeah, you seem a little more excitable than in your interviews. You were so mellow then. I'm like, yeah, turns out I was on a bunch of painkillers. And he's like, oh, I couldn't tell. So kind of funny story. I'm going to go back to building Legos now. We'll see. Do you think that YouTube is going to demonetize my stream for telling that story? We'll find out if there's a yellow check mark that appears soon. Not yet. Okay, that's good. Thank you, YouTube. I appreciate your consideration. Okay. How much did it cost me to build my 7-pound thrust rocket engine? It cost me about $1,200 to build my 7-pound thrust liquid rocket engine. Oh, cool. Nanorax is going up on the first Dragon 2 flight. C-Bar, I no longer work for SpaceX, and I can't talk about anything I did for SpaceX while I worked there. I'm still under NDA. But I did work for SpaceX. Okay. Michael says that the Chinese are still behind. I wouldn't say that the Chinese are behind. They've built a lot of really cool stuff. They have several cryogenic liquid rocket engines running now, and their private space sector is doing pretty well too. I just don't think it's fair to say that they're the only ones innovating. Fog wants to know what the best way to learn SolidWorks is. Oh, CAD everything. Frog, if you need CAD projects, I'd be happy to send CAD project ideas your way. just pick a project and do them. I CAD rockets all the time. I would CAD just random rocket ideas. I would like make my own stage separation mechanisms. I would design my own TVC mounts, just all kinds of projects to start getting experience with SolidWorks. Okay. Let's see. We're building a 30K SRAD hybrid motor for Spaceport America. Any tips? C-Bar, don't either use nitrous or be prepared to explain to me the phase diagram in intricate detail. And as a second note, C-Bar, I am hosting a rocket competition this summer called the Sounding Rocket Design Competition that is going to be online only. It's not as much fun as Spaceport America, but it will have lots of prize money, and so you should tell your team to enter my competition this summer. We'll give technical feedback and lots of prize money, so you should totally enter. All right, Neutronium, thank you for joining my Patreon, but you have to remember, it's a secret until I announce it to everyone else. But definitely go back and watch the past live streams with the other person involved in that project. It's worth it. There's some good content. Okay. Nicola wants to know if Inconel works for a nozzle. Inconel definitely can work for a nozzle. I have made several rocket engines that use Inconel for nozzles. I've made several rocket engines that Inconel would not work as a nozzle for. It just depends on your application. Roman wants to know how much of the cost for a rocket engine is R&D compared to its material costs. And the answer is like all of it. The actual material costs of a rocket engine are relatively low. What's expensive is the number of parts you blew up figuring out exactly what you need in the first place. And you will be paying that off for the rest of time. So like, if you have like a little thermocouple and you just need a thermocouple for like a 3D printer, it's $10. But if you need a thermocouple for a rocket engine, it looks almost the same and it's made out of almost the same amount of material and it's about the same shape and it's about the same size. But it costs $800 or $8,000 instead of like $10 because they're just very tiny details you absolutely have to get right or it doesn't work. Ooh, r/CAD has CAD challenges. I should do that. That sounds like fun. Okay. iFolk wants to know if I was a part of USLI team. No, I was not a part of USLI team. I was, however, part of the Spaceport America Cup team. Okay, so this is Kaibo done. No, it is Kaibo almost done. There are 4 more parts I've got to click on. But after this is done, then we have to get on to doing, looks like, Destiny and Columbus. Oh, and Harmony. Okay, so that and that goes there. And then this whole assembly. Oh, and then it's got like this weird... Okay, I see. So then this piece goes through the back of Kaibo, and then all of Kaibo connects to node 2 like that. Ha 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 ha! Oh, that's so cool. I love it. It's awesome. That is wonderful. So then we need 2 more of these pieces, and then one of the dark gray flats, and then 1 white dot, and then one of these gray pieces. That goes down. So this right here, what we're about to do is the European experiment module, and it's called Columbus. I presume named after Christopher Columbus, and it is where it was the module that ESA contributed. All right, so this goes here, and then it's got another one of those black axle to shaft pieces. It goes there, and then it goes on the other side of Kaibo. There we go. So this is most of the United States orbital segment. It's missing the Quest airlock, it's missing the cupola, it's missing beam, but it's most of it. And just as I hypothesized, It goes right here. Voila! Haha. Weird. That totally shows parts that I do not have attached to my... Weird! Okay, so this instruction set right here definitely has pieces in the visualization that are not on my model, and they didn't come out of the bag that I used to build this part of the model. So I know, well, I theorize that I didn't make a mistake. It just hasn't had me add those pieces yet. Okay, wow, I missed a lot of CAD. A lot of the chat. Nitrous. Nitrous is scary stuff. Nitrous is scary stuff. Whoever said that, Michael? Yeah, I think that was Michael. Yeah, Michael, you're exactly correct. Nitrous can detonate, it can explode, it can make high explosives if you mix it with anything organic, anything with carbon in it. If you spill it on the ground, it makes explosives. If you spill it on some leftover cleaning solvent you left in your tanks, it makes explosives. People are like, oh, I'm going to be safe and not use cryogenic locks and use nitrous instead. And then they're wrong because nitrous is actually way more dangerous. Not that I have a religious argument about this topic, but people who don't understand nitrous have no business using nitrous. Frog wants to know if it necessarily has to be SolidWorks or if other CAD software would work. Fusion is okay. Fusion is not as good as other CAD packages. It's just not as good as SolidWorks. It's not bad. It's much better than other CAD packages, and it's free, which is pretty good. So if you can't use anything else, use Fusion. Otherwise, try and learn something else. SolidWorks has a lot of licenses for students, so if you're still a student, you might be able to get a SolidWorks license for free. NX, CATIA, very good CAD packages. VinFaz, well, you're just going to have to wait and see if you know what's going on with the leaks. I can neither confirm nor deny anything about the leaks. There haven't been that many leaks, have there? I don't think there have been that many non-Patreon leaks. Under which circumstances would I use Inconel for an engine, and when would you not? That's a really broad question. That's not going to have a fast answer. That would be like a 10-minute video all on its own. Unpopular opinion, Skylab greater than ISS. I would love it if we could add a Skylab size module to ISS. That would be so cool. But ISS is pretty cool. What can you use to make nozzles if you don't have machining tools or a 3D printer? You could try welding one cosmic, but not really a whole lot, sorry. You could maybe cast one. Do I have any recommended sources for learning material about the science and structural design? Yucca, there's a lot of material on structural design. I'm not sure I have a good, like, single point resource for it. I guess I'll keep talking about what makes good design materials in my videos. My new Solid Rocket Motors episode 2 just came out, and I think it's pretty good talking about, like, why solid rocket motor cases have certain design considerations. But as far as a general resource goes, I don't know of any good ones off the top of my head. Sorry. Guerrero wants to know if I can say some inspirational words about the space program. Well, here's what I have to say. Space solves scarcity. The abundance of material resources in space allow us to give to every single person who has ever lived, who will ever live, and who is living right now, the level of material wealth that is currently enjoyed only by a select few. The resources of space will eliminate scarcity and allow us to take the level of care that is required for us to take care of our fellow humans to be decent people. For example, the catalytic converter in trucks that reduces their emissions requires platinum. There is not enough platinum on the Earth to make a catalytic converter for every car. But there is an asteroid that takes less energy to get to than the moon. It has enough platinum to fit every car on Earth with something like 35 catalytic converters. That is something the world could sorely use. And the resources and the abundance and the room to grow and expand our horizons is what makes space so essential to the future of humanity. And that's why I believe it's important that we democratize space. We make space accessible to everyone, because that level of access to resources means that the world will be a much better, much happier, much more equal place in the future. Okay. Was I passionate about rockets or engineering since I was a child? Yes. When I was 3 years old, I knew I was going to be building rockets. I thought I was maybe going to be doing space law instead of space engineering, but I got to space engineering eventually. What's the most effective way to get engineering coursework done and still have time to build rockets? Oh boy. Well, I don't know, because I built a lot of rockets and did a lot of courseware, and I think the solution was don't sleep, which I cannot advocate as a responsible, healthy life choice. Nicola wants to know, where do I buy materials for a liquid rocket engine? McMastercard? eBay? I've bought, probably by money spent, I have spent 10% of the amount of money I have spent at Online Metals, 70% of the amount of money I have spent on eBay, and 20% of the amount of money I have spent on liquid rocket engines I have spent on McMastercard. Now, there's a weird dichotomy there because of the amount of time I have spent on parts. I have spent 90% of the time on the 10% of the money, because some parts you just can't buy. Like, there's not someone who will sell you the part regardless of how much money you give them, so you have to buy the raw stock and make it from scratch. Okay, well, I have managed to successfully stop building the space station for a second, so I have to pick it back up. What time is it? We've been streaming for almost 2 hours now. It is 9:30, so we really need to pick up the pace of space station construction, which we will do right now. So we will turn this around, and I need to grab one of these gray pieces. So I'm going to do a less good job of reading the chat. I'm very sorry. Thank you all for participating, and I will get back to it from time to time, but I really have to build this. So if you have something really interesting, you can totally spam it, and I will see it eventually. Also, Joey, congratulations. I have just promoted you to moderator, in case anyone misbehaves while I'm not paying attention to the chat. Don't feel any particular responsibility to use that power, but I know you are a good human being. Okay, so we added that and that, so that clicks to there, and then this whole thing needs to go on the stand. How does it go on the stand? It goes, just chill there. That is not satisfying and does not make me happy. That's super lame. Really? That's how that goes? Oh, that's how that goes. Is that supposed to click there? There's nothing holding that there. Oh, because it's about to add something on the other side of it. Ha 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 ha. Maybe? No. What on earth? That is so lame. I've got to be doing something wrong. Does it go like this? Ah, that is what I was doing wrong. Okay. I bet you. Yep, I had it on backwards. So smart, Charlie. You are so smart. Absolutely brilliant. Okay, we fixed that. That is fixed now. Michael Morrissey wants to know, Agile hiring any off-site interns that are in high school? No, unfortunately, we've hired all of our interns for the summer, and I had to turn down a lot of very, very, very skilled people who are seniors in college and were absolutely brilliant, and I felt bad about it because there were more awesome people than there were jobs to give, and frankly, I'm not sure if I would have gotten a job if I had to compete against all those same people. They were some really smart people. Okay. Yeah, everyone who needs to go to sleep, go to sleep. People make wise life choices. I have a Lego to finish, and I will make poor life choices to finish this Lego. If you would like to join me, I will support you making poor life choices, but encourage you to make good ones as well. Okay, so we've got this piece here, and we need to add 2 of the little ovally shaped bits again. That light just keeps getting dimmer and dimmer. I can't tell if the light gets dim and then like slowly gets bright, or if it just like halves in brightness every couple of minutes and my eyes just adjust to it. Two. Yeah, these are the light gray ones. 3 and 4. Okay. Yeah, Yucca, I'm always happy to share advice. Advice is fun to share. I appreciate helping people who appreciate my advice. Okay. So now we put these 2 more right angle pieces on top, and then we add 2 more of the ovally bits. These aren't really ovals. I would guess I would call them like the opposite of a slot. What's the technical name for the geometric inverse of a slot? I don't know, but this is like what's left over after you punch out a slot. Okay, once that is done, another light gray 4x2 goes on top. Oh, this is weird. This is like a communications dish or something. So it's a gray piece, followed by a light gray centering circle, with then one of these like 1 tall cylinders, with then a bottle top piece. And that goes, is this symmetric? This is symmetric, so I gotta pick which side it goes on. That goes there, like that. And then one of this white textured cylinders goes on top. And then this weird, like, 2 axle piece. Holy cow, we are way off the reservation now. This is just getting crazy. That and that. I don't know where these instructions are taking us, but I'm following them. That goes there. And then this gray piece. So my new strategy here is to see how quickly I can put everything together in between like trips to the chat. There we go. Okay, that was hard. Okay, so this whole assembly goes... Oh, this is the Quest airlock! Quest airlock, ladies and gentlemen, right there. Ha ha ha! Yes! Okay, that's so cool. So this whole assembly then, I guess, goes with this facing this. So this is the Unity node and the Z1 truss connection. So this is the Z1 connector right here, and this is Unity right here, and this is the Quest airlock. Ah, that's so cool! I love it. This is awesome. Brilliant. I'm going to read the chat quickly now. At Charlie Garcia, I recommend a blue light filtered glasses if I'm staring at a screen all day. I have no trouble staring at a screen all day. That probably says bad things about me as a person, but on the bright side, it makes it easy to do my job. And I love blue light. I add blue light to everything because I think it makes it look sci-fi. Let's see. It's going to take Charlie twice as long to build this because he's streaming. Yes, it's definitely going to take me twice as long to build this. It took me like 8 hours to build the lunar lander on the 50th anniversary of Apollo. Joey is entirely correct. 4 hours with friends is better than 2 hours alone, and goodness gracious, quarantine is killing me. I am way too extroverted to survive quarantine. I am just dying. But it's okay. We are saving lives by being responsible, and we should all do our part to make sure that as many people as can be helped are helped by our responsible actions. And my propensity to be social is less important than our ability to protect people. That feels important to say. Oh, cool. This is the primary antenna. Mark Watney would kill for one of these. And it goes right there on the Z1 truss. So this points at TDRS satellites. That's their high-rate data link. And then we need to make another one of these widgets, which is the other silver dish and the other gold antenna piece, and this other white arm, which is somewhere. Here it is. And then like a little widget that extends off of it. And this is the backup arm, except the other way. There we go. Backup telemetry. Awesome. That's cool. Okay, what are we making now? Now we're making parts of the Russian segment. So we need a gray flat piece, a gray cylinder piece, and then another gray flat piece. And then we need the gray piece with a hole in the side, and then a blue axle to shaft, and then this gray right angle goes here, and then an oval. I see the chat moving, and I'm resisting the temptation to look at it. Do you see how strong my willpower is? I'm not looking at the chat. That goes there, and then we need the light gray centering piece, which goes there. And then this cap piece, which goes on something else. So we take this gray piece, put the cap on it, and it connects onto this. Oh, okay, cool. Is this maybe not part of the Russian segment? Nah, this is part of the Russian segment. It just looks more like the US segment because there's not a different diameter to use for the Russian segment. Or maybe this is node 3 in the cupola. Yeah, that's exactly what this is. This is node 3. So there are the 3 nodes and then the US laboratory. So there's Unity, Harmony, and I think Tranquility. And those are the 3 nodes. And then there's the US lab, Destiny, which is in between node 1 and node 2. So node 3 sticks down off of node 1. Node 1 is Unity. It's the very center of the space station. It's like right here. The lights just got brighter. Eyes them suspiciously. And so this is node 3, and it has the cupola, and it has the logistics module, and this is also where Beam is attached. So this is cool. Okay, I'm going to stop segueing and start building things. Okay, so we need the other blue axle to button, which goes there. Ah, so this is Beam right here. That's what this little white widget is. Ha ha! Ha ha! Okay, that's exciting. So we stick that in, and then we stick this on there, and then we've got a little beam. Ha 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 ha. There we go. Beam. Beam has been added. Beam is the Bigelow Expandable Activities module, and Bigelow just went out of business. They fired everybody. Bigelow, total jerks. They were renowned for having horrible management, but they built cool stuff. In case you were curious. And now we attach this to node 1, right there. Yep, okay. So we have now added this to node 1 of the space station. Awesome. The next thing we build looks like part of the Russian segment, for real this time, because it has solar panels, so I actually believe it's part of the Russian segment. But first, I will read the chat. Okay. Michael Moresi wants to know what I do at Agile. I was hired as the lead propulsion design, manufacturing, and production engineer. I have since transitioned into a role as a vehicle engineer, working on vehicle systems, tanks, and propulsion systems, which means I do a lot of engineering and mostly manufacturing work, so like working with our vendors to get our parts made as we designed them. But from time to time, I get actually like design new nozzles and new injectors and stuff, which is definitely the funnest part of my job. Paulo, welcome to the stream. Okay. Good luck, Michael Moresi, studying for your physics test. All right, Jay Murphy. Astronaut time is a hot commodity. Yes, and adding a 7th astronaut up from 6 will almost double the amount of science we get to do on the space station, because the first 5 astronauts are basically needed just to keep the station running. So going from 1 full-time science astronaut to 2 full-time science astronauts, that's not actually how it works, but when you do the time accounting, it means the same thing. It's going to be super impactful. Okay. Besides Angara, is Roscosmos doing anything exciting? Yes, Roscosmos is working on a new crew module to replace Soyuz called Federation, and it's supposed to fly in 2022. I will believe that when I see it. I'm a little skeptical. I apparently have an interesting laugh. I will decline to reprise it then. Yes, Sibar, you are entirely correct. Bigelow are jerks. I also hope someone sensible buys their. I hope Axiom buys their AP. We should all tweet an Axiom and ask them to buy Bigelow's IP. That would be the best case scenario for everyone. That would make me incredibly happy. I would love that. You know, Sibar, I work with Canadians at SpaceX. It's entirely possible to get ITAR licenses. I think people are too pessimistic about that, but it is like actually entirely possible to get ITAR licenses. There were 2 Canadians in my group at SpaceX. One of them left to go work on solar panels, and I think the other one is probably still there, running lane 4. I hope he's doing well. He was really cool and very nice. Okay, so we take this, and then we add this piece here, which is going to be where we mount the solar panels. And then we add another one of these weird oval pieces that I have literally only seen on this kit. And then we add a dark gray circly bit. Sorry, then we add a gray circly bit, and then a dark gray circly bit. And then we're going to add one of these little like circly doodads that marks it as a Russian capsule. Yep, as I predicted, we add the red rod, and then a little washer bit, and then a gray plate. Oh, weird. Okay, sure. Whatever, I guess. This is interesting. I guess you're allowed to put the pieces together that way. And it goes, okay, so this is a progress docked to the underside of node 3. So this is a progress module. And it goes here. Awesome. Okay. Wow, there's so much left to go on this. We are so hosed. There's no way this is getting done, and yet it is getting done. Okay, so we take this big red rod and we put it in here. And it's just going to stick out. I feel like it's supposed to slide in further than that, but it doesn't, so it won't. And now I need this white disc. It goes like that. And then one of these little gray spacer bits. Joey wants to know, does Beam have any active components, or is it just a passive structure? Beam has instrumentation inside of it to monitor its health, but after it was commanded to open, it no longer has any active components to command. So since Beam doesn't exist, there's no bad things happening. Also, I'm not sure that Beam has ceased existing as a corporate entity. I think probably what the scumbag owner people did was fire everyone for the pandemic, and they'll hire everyone back after everything's said and done. I don't know that for a fact, but it would not surprise me if that were the case. Okay, so now we need one of these cross pieces. One of these, like this. And I need one of the little single pin. Yeah, there we go. Okay, so it goes on the thin axes like that. That's kind of new. I like it. I like it. Gold rod goes up. And then gray piece, and then white button. And then black sphere. And then this white widget. Oh, fascinating. Okay, I see how this is working. I see. And then we're going to have the solar panels off the side of this in here, like that, and like that. Yep, called it solar panels. Go there, and go there. And then this is going to go here. Oh, so that wasn't a progress. That's a Cygnus. Maybe, possibly. I don't know. Some of these are just random cargo resupply vehicles that are like kind of nondescript. I really wish they'd made it a little bigger. It's just kind of almost too small to see what's going on. But that goes like that. What I really should have done was I should have memorized where everything is on the space station so I could talk about it on stream and not sound stupid. But that would have been too clever for me by a half. Also, I don't have that much free time. Okay, so this goes here, and then this is the next thing that slides on. Like that. So this is going to be Zvezda, which is the first module in the Russian orbital segment. With these solar panels. And it needs another white panel combo. Like that. So C-Bar, you have to be sponsored for one by the company you want to work for. So you need to find a company you want to work for, convince them to hire you, and then they will get you an ITAR license. C-Bar, Canada Arm is awesome. You literally cannot overrate how cool Canada Arm is. Actuated mechanical components in space are very non-trivial. Yes, actuated components in space are very non-trivial. That's the easiest way to put that. Canadarm has like all the degrees of freedom. I think it has 7 degrees of freedom in the arm and like 12 more degrees of freedom in Dexter. AMG Wagon, a friend of mine actually asked Chris Hadfield, the Canadian astronaut, how you pronounce Canadarm on Twitter, and he answered. I think his name was Wilder Parks. Maybe it was Caitlin Hoover. I don't remember, but you can go on Twitter, and I probably liked or retweeted their post. So he definitely answered that. I think it's Canada Arm, fully pronounced both. Okay. Let's see. The next thing we have to build looks like another Progress or Soyuz, which is going to be another one of these. Another one of these with the white dot on the bottom. And then the rod through it. This time just a gray rod instead of a gold one. And then the bally bit. And then this bit. And then 2 of the solar panel attach points. And then the solar panels. And it slides on exactly the same way. I'm running out of hands to hold things and push stuff together. Okay, got that. Oh wow, what would you know? Another white piece with a flat panel facing the bit we just slid on. This has been the pattern for like the last 4 pieces we've done. And then a white piece with these connectory bits that go on top and bottom. So these will hold the big solar panels. I think these are actually meant to represent radiators on Zvezda, but I don't know for sure. So these, I think, are actually folded up on station. No, these are actual solar panels, but they are folded up on station. Okay, so we got that, and these are going to slide on. Oh, who'd have guessed it? Boom. Then this with a single gray piece on the middle back. And it just slides right on home. Houston, we have a problem. I don't know if you can notice the like massive red gap, but something is not fitting. And I have a hypothesis that it's here. I have broken the space station. This is a problem. Let's see what I can do to get more space. So that goes there, which means that this should be able to go in like that. But that means that this yellow piece doesn't go in far enough. So I needed it to go more this way. Oh boy, this is no bueno. I have built something wrong. Probably. I think the technical term is uh-oh. Uh-oh. I know that goes there. We go there. This seems like a problem. Problems. I don't know what the problem is here, so we're going to take a moment to review the book. This red piece should be 12 studs long, which it is. So the next trick is going to be to find the yellow piece. Okay. The yellow piece sticks out too far. The question now is, why does the yellow piece stick out too far? Yellow piece is the correct length. So, with that in mind, we must analyze why it is sad. So we've got that. That feels like a piece that I may have either forgotten or lost. It's right there. Okay, so we're debugging situation. What has happened is the pieces are not getting to be the correct length, and this is bad. So what we need to do to fix that is we need to make this the right length. So we've got this here, and this here, with this like this. That's better. Okay. I don't know what I did different this time, but whatever I did different appears to have made an improvement in the situation. So that goes there. And then we've got this, which should be able to fit up like this. But it doesn't. Okay, the problem is still not excellent. So now let's check the stack up again. So that should be one, two, three. Yeah, so that's correct. So we didn't make a mistake there. Let's turn this back to the live workbench. Okay. So we've got this, that, there. And the amount of yellow sticking out was correct. And the amount of red there is correct. So now we keep going forward. All right, so then it goes gray piece, white piece, spacer piece, which we've got. And then it goes Soyuz progress thing, which we've got. And then it goes 2 white pieces, which we've got. Ah, I have found the missing piece. Nope, no I haven't, just kidding. Then the solar panels, which we have got. And then 2 more white pieces, which we have got. And then another Soyuz, which we have. Ah, I have found the missing piece. I broke that piece, but I found what I did wrong, which is that I needed to add this widget here, and then these widgets, and then the solar panels, and then this. Wow, guys, that was really hard, guys. Really, really, really hard. Okay, I have probably missed a lot of chat. Differential equations are very useful. After having worked for SpaceX and worked for Agile just last week, I saw my first differential equation as a professional, and I was very scared. Guerrero wants to know why I decided to upload to YouTube. To be honest, I have always enjoyed sharing my knowledge with others. I was a space camp counselor for several years, and I was a museum docent leading tours of space museums, and I knew I wanted to build a rocket engine, and I thought that maybe other people wanted to watch me build a rocket engine, and so I made videos, and it turned out to be okay. Let's see, end up in top 10 at Spaceport America Cup, and the faculty says, do whatever you want, guys. Oh, well, your faculty is nicer than ours. We won, and they said, you better win next year or we'll cut your funding. Problem with student rocket teams is that they can be extremely dangerous with input. Yeah, I mean, Michael, you need a culture of safety, and the problem is that you have a half-life of 2 years on your team. Okay. IREC is Spaceport America Cup. The IREC competition used to be held in Green River, Utah, and now they hold IREC at the Spaceport America Cup. So they're kind of interchangeable. Okay. What further instructions need to be done? Oh, we've only got like 30 pages left. We can totally get this done, guys. We are so going to get this done. That is what optimism sounds like. So now we need to make another Soyuz. So we're going to do that by taking another one of these, putting another white button on the back, sliding that down, and then putting another one of the black balls on the front, adding the solar panel widgets, adding the solar panels themselves. Boom, boom, boom. This thing is so unbalanced, it's kind of like bad. Okay, well, we'll fix that eventually, I guess. Bag 5. We are on a roll now. This is bag 5. Get the pocket knife. And get the pocket knife back out because we've got 2 more little bags to open. Okay. Oh, bad. I just put a piece on the floor, which is like the worst thing to do. Oh. Hello. I said I was going to stop bumping the camera, but I obviously was still lying then. Okay. Oh, thanks, Joey. I was just trying to remember how he said it. I didn't want to misquote Commander Hadsfield, who is too cool to be misquoted. Let's see. All right. Mic sensitivity is killing you. I'm sorry. Is my mic sensitivity bad? I can't actually hear. I have audio turned off, so I'm going to eventually get better audio. I have had it on my list to buy a new camera with an external audio port for like several years now. And when I started doing YouTube, that became suddenly more important. I've just still not quite gotten around to it. So I think I might pick up the new T7i from Canon. I have the T6 right now, which does not have an external audio in port, which is just unfortunate. Oh, these are the radiators. That's the only thing that could possibly have this shape. That's exciting. I love how they gave the radiators the distinctive shape. That was smart of them. Okay, so we've got that. And then 2 more. 1 and 2. Come on, there it is. We've got that. And then we need to flip it over and add this gray widget on the back. And then one of these smooth pieces. Oh boy, where are these smooth pieces? Oh, is it 2? No, it isn't 2. Weird. Okay. It's right here. The problem is that it looks like every other one of the smooth pieces, but it has bumps on top instead of on the bottom. Okay, so we got that. And then we flip it over again. And then we need the gray, light gray piece with the hole in it. Okay, so this is how we're attaching the radiators, through that little stud connector right there. And then a big flat white piece like this one. Is that it? That is it. Okay, now I need to build a second one. Yeah, that is in fact what the instructions say. Sometimes, every now and then, it's good to check what the instructions say, even if you think you know what the instructions are going to say, unless at least you make a fool of yourself. I've definitely like built things before and been like, wow, why is this wrong? And realized I forgot to mirror it, which is obnoxious. So then I need another one of the gray back pieces. Let's see if I can do this from memory. I give it like a 20% chance of being able to do it from memory. There's that. And then I need the one of these on the end. And then I think I need the light gray piece on top. Probably. I assume so. Here it is. Are these the same? Nope, I forgot a piece. I told you I couldn't do it. I didn't have any faith in myself. I correctly did not have faith in myself. Okay. And then these mount here and here. Awesome. Oh, this is looking so cool, guys. I love it. Now we need to add some more antenna-y bits. One of these little toggly lever bits goes let's see, the whole thing orients like this, and it goes here. I don't know what this does, but I assume it does something. Maybe it's an omnidirectional antenna. And then one of these like weird clicky bits again. Where's the clicky bit? Woohoo! There is the clicky bit. There it is. Where does this go? This goes here. Fascinating. I wonder why they didn't have us do that earlier. All right, now we need this right angle bit, a gold stud. We are like on the home stretch, folks. We are almost there. Joey, I need a camera audio input because I am not a full-time video engineer person type thing. So I just got to be able to like plug the camera in and plug it into my computer and like make it work because I don't have time to mess with it. What I'm really saying is I'm lazy. That's my problem. I'm lazy. I build rocket engines for 10 hours a day and then build rocket engines for the entertainment of YouTube for another 6 hours a day, and I'm lazy. Okay. Yeah, Guero, go to sleep if it's getting late for you, man. I do have work tomorrow, so I need to finish this quickly. Legally Bred wants to know about gas injectors. What do you want to know about gas injectors, Legally Bred? I know a few things about gas injectors. Seymour, I don't actually care about how many views I get. I care about the quality of the views I get. And you folks have proven to be a most stimulating audience. Thank you for your participation. But yeah, really, I'm just trying to like, most of what I do on YouTube is not live streaming. It's mostly making videos about how I build rocket engines. So in lieu of me like going to all the work of figuring out how to run a Twitch account, I think this is the best solution. Okay, so I've got that, and then this widget goes here. I still don't know what that does, but it's there. Now we have to make another antenna dish. So we've got this, this, and it goes, wow. So pretty much the outside of the space station is just all various antennas, which I guess kind of makes sense. Maybe I shouldn't sound surprised by that. So now I need 3 of these little connecty-do arms, 2 and 3. One of these white light gray centering panels, and 1 white dot. 1 white dot is there. And there's the light gray centering panel. So the white dot goes on that, and then it goes here. And then 1 goes like this. 1 goes like this. And where does the 3rd one go? The 3rd one goes here. Okay. Then we need this white flat disc, this flat gray panel, one of these light gray clicky-doos, and one of the ovally bits. There we go. So it goes like that, and then this goes on top. So this is like another antenna type thing, and it goes here. And then a white bar, like this one, goes between these two. Right there. Shiny. Next page. Look, we're just burning through these instructions. We need a light gray bit. We need a right angle light gray bit. Not that one. That one right there. We need an ovally do bit. Like that one. We need a single white dot, which is that one. We need a single white square, which is that one. And we need a single gray square, which is that one. Okay, so we take this panel. Gray bits go up. White dot goes there. Gold dot goes there. White dot goes on top of gold dot. Gray oval goes underneath everything. And it goes here. I still don't know what any of this does, but it looks like science, so we'll assume that's what it does. Now we need a dark gray panel, a single white square, and a single white dot. And it goes underneath. Fascinating. I assume at some point in time, the person making this Lego set just said, I want to add some detail, and just like hack together random details. But it would be really cool if all this was like legit science equipment that I just don't know enough about the ISS to tell you about. Gray bit flipping down, then another white square. Do we have any more white squares? I assume we do, probably, because they asked me to put one somewhere. There it is. And then we need like this white angle bit. Such a weird piece. There it is. It goes like that. And it needs another one of these antenna pieces, which goes right there. And lo and behold, sure enough, it's another antenna. Surprise, surprise. Antenna. And this assembly goes here. Next page. All right, I gotta read the chat real quick. Discussion of CubeSats. CubeSats are awesome, and if you want to work on CubeSats, my friend Ben from the Flame Trench does a really cool CubeSat discussion in the Flame Trench Discord, which you should all talk to Ben about joining. Ham radio satellites are also awesome. That was one of my first like ham experiences, was doing satellite contact. Let's see. Yeah, Joey's right. You don't typically weigh the amount of fuel you have left. You typically count how much you've used. I defer to Joey on how long it takes to build a CubeSat. I don't actually know how long it takes to build a CubeSat. My job is usually to get the CubeSat up to space. So usually, I just see the CubeSat once it's done. So we've got another one of the clicky-do pieces, then an oval, then a white circle, then a white square. This is getting to be pretty familiar. White circle, white dot, followed by a white circle, then a white square. And it goes... We flip this around, and it goes over here. Okay, okay, that's cool. That's cool. Goes back one, though. Goes there. Okay, next. This looks like robotic arm parts. This widget, one of these widgets, with one of these widgets. This is definitely some kind of robotic arm. I don't know if this is Canada arm or something else, but there's nothing else it can be. This goes here. And then another one of the graspy widgets, and then a white dot with like the little pokey uppy bit right there. Yeah, has to be Canadarm. Those 4 pieces are still there, and I don't know when they got there, but I didn't put them there. They have to be these pieces. That one, that one, that one. Oh, come on, there's got to be one more. in that one. Yeah, those pieces have to be what's going there, and I just haven't added them yet. So I don't know if I missed an instruction or what, but this attaches. Oh, it attaches to the gold piece. Okay, that's clever. So now you can slide the arm up and down the whole length of the thing. There we go. Robot arm. Oh, that's awesome. Ah! I broke it. I broke it. It is broken. It is now fixed. Anyway, robot arm. Look at how cool that is. That's just awesome. I love it. Okay. We'll get the radiator straightened out again and put it back on its plinth. Okay. Robot arm. So now we're going to build other pieces. I don't know what these other pieces are, but I assume they're interesting. I have to build 2 of them, so we'll just build 2 of them at the same time. That feels like a smart thing to do. Another gray piece. Then white squares. Then 2 of these gray pieces. Put one of these plugs through both of them. And then mount it there. That's kind of an interesting contraption. I don't know what they're going for here, but I'm sure it's going to serve some fascinating purpose. So that goes there. Let's see. Legally Bred is trying to design a rocket engine, ethanol, and GOX, and I understand that liquid injectors, but mostly due to lack of me researching it. I don't know anything about gas injectors. Oh, reposts are fine, because I'm not reading the chat very much. So the trick to gas injectors is you want shear action to break up the fluid into droplets, into very tiny droplets, so that it atomizes. So coax injectors, shear coax injectors, swirling injectors, those kinds of things are great for gas injection. Or like shower head type things work okay for gas injection. When I'm doing CAD, do I listen to music? Yes, I always listen to music when I'm doing CAD. I don't think I could do CAD if I didn't have like something on in the background. I would go crazy. Joey, you should be able to post links now that you're a moderator if you want to throw a link in the chat to your lab. C-Bar, I can't, it's a Patreon only Discord, I think, unless Ben invites you. So if you want to go on Twitter and find the Flame Trench and tell Ben to invite you to the Discord, he might. He does free Discord invites for CubeSat people. Joey, it's funny, I was just downloading that model last night because I was using it to make my new Dragon Docking and Rendezvous program. Okay. Here we go. And then 2 more of these white pieces. I assume these pieces here are for the solar panels. I say assume because I actually have no idea. I'm just totally winging it. So take 2 of these pieces. Oh, weird. Okay, so you put them in this way, and then you trap it in with the second one. I guess it's a good way to keep it from coming out if you don't want it to come out on accident. Like that, and like that. And then slide the second one on to trap them. And then put that there. Awesome. I'm switching from wine to Dr. Pepper because it's got caffeine in it. All right. So then, now that we've got that done, we put this white panel on top just to close it out. Oh, and I see how these fit. These will click in like that. Awesome. That makes total sense. Beautiful. So now we need 2 flat white squares and 2 of these, which means I need 4 flat white squares and 4 of the right angle pieces because I'm building 2 of 2. And 2 times 2 is 4 because I do math, because I am an engineer and I'm smart. And 2 times 2 is the most advanced math you will ever need as an engineer. I can confirm this. So that. And then one of these widgets and a flat panel, which is followed up by one of these widgets and a flat panel. We can flip it over. These pieces go on here and here. Wow, we're back up to 32 people. We were down for 23 people there for a minute, and I thought the stream was kind of dying as it got late, but more people have joined us. Welcome, more people. Thank you for joining us. We're building the International Space Station out of Legos on livestream while talking about space stuff. We've got a fascinating conversation going on in the chat about how CubeSats happen, and sidebar discussions about cool places to work and people that build cool things. Okay. All right. Ladies and gentlemen, I would totally believe that Joey could destroy people in Yahoo checkers. Joey, do you play chess? I bet you would be good at chess. You seem like someone who would be good at chess. You'd probably kill me, but it'd be fun to play. All right, next pieces that need attached. We need to put these arches over on the top. There and there. And it looks like also some light gray pieces that go there. And then 2 white panels that go 1 down from the end. There we go. We're getting there, folks. 1 step at a time. We are getting there. These and these. And another one. And another one. Now this is just getting repetitive. Earlier I was complaining about symmetry, and now I'm complaining about the lack of symmetry, and now I'm complaining about having to do everything 4 times to maintain symmetry. I guess I'm just impossible to please. Okay, so you got these, go like that, and the white piece that comes off the back. And then another one of those, another one of those, and then one of these gray pieces across the top. And then this flat gray panel there. And this is the end. Oh, weird. That's not maybe how I would have chosen to end it, but I think it counts. So now I just need to duplicate all of that. Like that. Like that. And the gray cover piece. And then it clicks into place like that. Very satisfying. And then, as predicted, gray ball goes into that clicky-do bit there. Like I said, the gray ball goes into that clicky-do bit there. Same thing on the other side. Okay, that's pretty cool, guys. This is getting awesome. it's still like not the most balanced Lego set I've ever put together. Oh. Oh, these are the solar rotary alpha joints. Ha ha! Okay, so this is how it tracks the sun. So, all right, everyone, science lesson time. This axis through the spacecraft right here is called the V-bar, which stands for velocity bar, which means that as it goes around the Earth, this is always pointing forward. So if the Earth is in the middle here, the Earth is down, this is always facing the Earth, and this is always facing forward. What that means is that the sun moves in the sky. It moves both this way and this way. So the solar panels can rotate this way to track, and then on each of these axes, the solar panels can rotate like this to track. This is the solar rotary alpha joint that we just created, and it looks really cool, so I'm excited. So now I need to finish putting together the parts on the solar rotary alpha joint, which is there, and there, and same thing on the other side. Okay. Holy cow. Awesome. Awesomeness. I love it. Matt Martinez wants to know if I was doing the Sprite project on my own, what is something I would do differently? Well, something I would do differently but not better is I would do the guidance differently because I don't know how to do the guidance as well as Joe does. I nearly failed my guidance class, my controls class in college. It was a near-cut thing. It was a very close thing. But I passed, and I graduated, and I am an aerospace engineer now, and I can have people like Joe do the controls for me so that the rockets fly straight and do not crash. Legally bred. You can make injector types work for either liquids or gases depending on what you're using. You just change some of the parameters. So gases are lower density, so to get the same injection velocity, you have smaller elements. Sorry, larger elements. Okay. So now we take these hooks, and they go into the little pieces I just installed. There. I'm going to break this thing. I just know it. This is not the most delicate model I've ever built, but it is not, like, astonishing me with its robustness. You can kind of really tell this thing is meant for microgravity. Okay, got those done. Oh, these are the radiator. Are these radiator panels? Yeah, I think these are more radiator panels. Really? I didn't know there were radiators out here. It would make sense. I don't know what else they would be. I thought the radiators were here and here. Give me a second. I gotta Google this. This is gonna bug me. International Space Station. Yeah, these are totally radiator panels. I knew these existed and just forgot. So these are zigzag folding panels on the real space station, and they are obviously not zigzag folding panels here. So now I see what they are trying to be, and and I understand. I understand what they're going for. Okay, those are the radiators. So these are going to be the solar rotary beta joints there and there, which come from bag 6, which we now get to open. This is the last bag, folks. We are almost done. We are coming to a conclusion. We're almost there, and many other such platitudes about being near the end. Which is good, because it is well into the evening. Ooh, that was catastrophic. Well done, Charlie. Well done, Charlie, you smart, smart person. This is probably going to involve me crawling around on the floor to recover pieces. All right. I think that's all of them. Now you can all berate me for my foolishness in chat, because I should have known that was going to happen and taken more care to avoid it. See, look, if I just opened that bag like I opened this bag, there would have been no problems. But instead, I had to get cavalier about it, and then I made a fool of myself. Joey Murphy wants to know why the real-life radiators have zigzags instead of just folding out to flat. It's because they stow. When they retract for launch, they retract in like it's like a scissor lift style mechanism, but half of the scissor lifts are just empty, and the other half have flat panels with ammonia cooling panels in them. Okay. Good night, Seabar. Okay, we are going to push to completion. Push to close, push to close. Here we go. Spread the pieces out. What do we need? We start with one of these gray pieces and one of these black axles. Follow it up with one of these long, 11 stud long light gray pieces, which is this one. Next piece on, gonna be one of these. We put in 2 of these side pieces, here and here. Then we turn the page. Oh, we need 8 of these. Holy cow. All right. I'm not sure if I can count to 8. That's a lot of numbers, and I need my fingers for something else. This is going to be, this is the battle right here. This is what decides if we get this done tonight, is how quickly I can build 8 solar panels. You know that scene in The Martian where they're like, they're talking to JPL, and the director of NASA is like, how long will it take you to build a pre-supply? And JPL goes, it'll take 9 months. And he goes, you have 3. And then the guy like turns away in panic, and the director of NASA, Teddy Sanders, goes, he says, don't give me that. In a second, you're going to turn back to me and say, the overtime alone will be a nightmare. And then he turns back and says, the overtime alone will be a nightmare. And he goes, just do it. And then the JPL guy says, we'll do our best. And he says, Mark dies if you don't. Well, no one will die if we don't get this done tonight, but this is a matter of pride. I have personal honor at stake here. So we're going to get this done. So I am just as quickly as can be done. So that's 4. So that's 1 flight set right there. So that'll do the S1 and the S3 trusses. And this will be the 4 and 6 trusses right here, I think. So the even trusses are on one side of the space station, and the odd trusses are on the other side of the space station, just so you kind of know what that numbering scheme looks like. With then the Z1 trusses right in the middle, right there. This piece. This piece. All right, that's 6 done, only 2 left. 2, 3, and 4. And then that piece and that piece. All right, 8 of these T-bars done. Next page. Wow, okay, so now we need these gray bits. This is what you need an assembly line for right here. Like, this is when Elon says that, like, it's not about building the spaceship, it's about building the factory that builds the spaceship. This is what he's talking about right here. Okay, so that's 8 of them there, and then they need yellow bits in each end. Okay. Everyone who's headed off to bed, thank you for the time you spent with us. It was a lot of fun, and I look forward to seeing you on the next stream. But Max is committed. Thank you, Max. Your dedication is appreciated. I, too, am here until the ISS is done. Interstellar Space Agency wants to know if you glue a servo to a 3D printed fin, will the fin rip off under force? Yeah, probably. Joe Barnard tried that, and it didn't work so great. Joey, it's always fun to watch those movies again. The other one I have it done for, not nearly as good, because I haven't watched it in a long time, which is kind of sad, is Apollo 13. I used to know it much better, but I still know it pretty well. Okay, so that's done. Now we need 8 of these. 1, 2, 3, 4, 5, 6, 7, 8. Okay, next. Set these aside and get these. And I need to make 2 of these for each one, which means I need to make 16 of these. Goodness gracious. How does this work? So you take one of these and stick it on the end. 2, 3, 4, 5, 6, 7, 8. That means we're halfway done. 9, 10, 11, 12, 13, 14, 15, and 16. And then it needs 2 sets of these each. So that one, and then that one. Wow, okay, this is going to be a lot of clicking. Seabar, I majored in aerospace engineering, well, technically the Department of Aeronautics and Astronautics at the Massachusetts Institute of Technology. Interstellar, it just depends on how fast you're going. Like, to be honest, the polite way to put this is, if you don't know what the force on your fin is going to be, then there's no way you can design a controller to make your rocket fly straight with the fin attached. So you should be able to answer very definitely whether or not the fin will come off. All the glues that I know of that are like good engineering grade epoxies have their strengths published as part of their data sheet. So if you know enough about the fin to use it to steer the rocket, then you know enough about the fin to determine if it's going to fall off or not. Here we go. I am just clicking all of these things on. It turns out to be surprisingly hard to click Legos together and read chat, but I'm trying. Maddie, hi Maddie, how's it going? Maddie, I believe the astronauts are being launched to the International Space Station next on May 27th, 2020, on a SpaceX Dragon 2 capsule that I think you probably know more about than me. Maddie is an absolutely brilliant engineer who also worked at SpaceX. Let's see. So Maddie definitely knows what's happening. She's just giving me a hard time, which she is well within her rights to do so. Maddie, you should tell us. Did you try and sneak into the demo mission? I don't know. I always looked at the cargo missions at the late load cargo, but there was always camera on the mice. So I figured if I snuck in to like sit by the mice on the cargo dragon, NASA would probably notice. Okay, well, the good news is this is the last one. The bad news is we're missing a piece, which is unsurprising given that I like threw pieces everywhere. But unfortunate, given that I hope I found all of them. So give me 1 second, I'm going to try and find that last piece. All right, found it. That was surprisingly challenging, but luckily it went quickly. It just involved me contorting in an interesting way to get to it. So now we need to attach the solar panels to the truss arms. So we do that by, I think, just clicking them into place. Surely it's that easy, right? And then I bet, if we look on the next page of instructions, yeah, it's going to tell us to do this. So then we click these on up here, and then we fold them down to hold everything together. Yeah, exactly like that. Okay, so we're just going to do that now like a bunch of times. All right. That one. Whew, we are almost there. I've been saying that for like the last hour, but like we are actually almost there this time. All right, that is 3 done. 4 to a side. So this right here is enough to complete 1 side. That's halfway. 5. Six. Oh boy, and here we go, almost. All right, I have not looked at chat in a minute, so what did I miss? Oh no, Maddie's a friend from school, but not my sister. My sisters are not Maddie. I do have 2 sisters. It is a table that I have put a blanket over because Legos go everywhere if you don't have a something for them to spend their energy on, and they make horrible clacking noises, which degrades the audio quality. And that is the last one. Goodness gracious, someone is dinging me. Okay. So, C-bar, yes, the solar panels actuate on all axes just like the real one. Maddie, I'm sorely disappointed you have not snuck onto Dragon 2. I don't think that they would have noticed. I think that you probably just could have stowed away behind Eric and Bo and gone to the space station. I think that's what you should have done. You let me down. Okay, so now we need to get the solar panels attached, which is, I think, just as easy as plugging them in. I don't see any instructions that say otherwise, so we're just going to do that. Oh, this is going to end badly. I did not consider that this is going to be out of balance the whole time we do this. Oh, I hate it. Oh no. Oh no. Ah! Catastrophe is brewing. I should have more carefully considered my attachment order. Oh, but I think this is going to be it. Yeah! Space station! And we can dock the shuttle too? Yes! Nope, just kidding, you can't dock the space shuttle. They don't actually connect. Okay, what's next? Is that really it? That can't be it. Yeah, that is not it. Okay. Now we have to send up the visiting vehicles. So we have, oh, they go down here. So that's the CST-100, and this is Dragon 2. Well, Dragon 1, but sure. And then it has us dock. There's already a Soyuz there. I can't send the Soyuz there. Oh, it has to go on top. Okay, we can do that. There we go. Got it. Check. Now I'm going to try and make all the solar panels look vaguely not awful. Okay. Hey! And the space shuttle goes right in the middle. Guys, check it out. Oh, this is so cool. Space station! Wow! Oh, that's so cool. I love it. Okay. What is the pile of parts to the bottom left? This is the spare antenna that belongs here. And I think everything else is just leftovers. Spare parts that LEGO provides for all the pieces that you normally lose. No comment, Joey, but I'm sure you could do some math on that one. All right, I think, ladies and gentlemen, Rocketeers of all shapes and sizes, that does it for this live stream. It only took 3 hours and 20 minutes, which is 8 minutes longer than it took Scott Manley to build it, which I failed. I've let myself down. I have been bested by the Scotsman. But I think otherwise, this was a ton of fun. Thank you all for joining me. And I think the next stream I do, it'll either be Kerbal Space Program, or I'm going to be rebuilding the compressor after I disassembled it now that the gaskets are in, so I can run some tests on some things that need tested that I can't talk about because I'm under non-disclosure agreements with other parties, unless you're on my Patreon. That will probably be like Thursday or maybe this weekend. I don't know. I'll figure it out, but I'll post a thing on the YouTubes when I'm ready to do it again. So, yeah. Yes, Ian, you may have made up subscriber points for being here the whole time. Thank you for joining us. It was so much fun to see everyone, and thank you all for being awesome. And I will catch you all on the next stream.